Thank you for viewing the Multiplicative Thinking webinar for grades 3 through 5. Before I get started, I'd really like to recommend that even if you are a 3rd, 4th, or 5th grade teacher, that you go watch the primary numeracy webinar, because even though that webinar does not have a direct connection to the curriculum that you're teaching right now, you'll see how the foundational gaps or holes that students have when they leave the earlier grades can affect what you're trying to do with them in the upper grades. You can go to numeracyconsultants.net and find that webinar. I hope you enjoyed today's webinar as well. Thank you. So what you'll be learning about today, what this webinar is about, it's about the Multiplicative Assessment Program. And you guys are going to be leaving today with a ton of free resources, assessments, frameworks. On the next slide, we'll go over all the things that you'll be receiving today for free. Just so you know, at the very end of the webinar, I will show you where you need to go so you can get your free resources. But first of all, the Multiplicative Assessment Program is a supplemental program designed to develop multiplicative reasoning. And again, it's a supplemental program, which means it's designed to be used alongside with your math program, not take the place of your math program. It's designed to be done 10 to 12 minutes per day, a 5-minute mini lesson, 8-minute practice piece. And imagine this, if you do it 4 days a week, that'd be 48 minutes per week, 192 minutes per month, and 1,728 minutes over the course of a school year. And these are highly focused, high quality minutes of instruction that your students will need, because your math series, no matter what math series you use, it's just not going to have enough development in it for some students to have a sort of a fluent understanding of what multiplication division is. It can be done in a regular classroom, it can be done by an intervention teacher, or it can be done by a special education teacher. So there's a lot of flexibility if you're going to do a whole group or if you're going to do it with a small group. And finally, the focus on building a strong foundation, not just for now, but for later, and then, rational numbers. So the idea is have your students have a strong foundation, so when they get to rational numbers, which is fractions and decimals, which is, in 4th and 5th grade is almost taught as soon as you work on multiplication division. That's the next thing you work on. And the idea is that if they're going to struggle, you want them to struggle with the rational number aspect of it, not the multiplication division part. But often what happens is when you get in the rational numbers, students don't have a solid foundation of multiplication division, so they're struggling with both the multiplication division and the rational numbers. Now we are going to go over all of the free components that you will receive today. First is the Multiplicative Thinking Assessment. And the Multiplicative Thinking Assessment is very similar to the primary numeracy assessment in that it will give you the essential data that you need to know about your students in order to improve their skills. This assessment will allow you to find what level of development your students are at, and then you will be able to record their scores and create a baseline data for your instructional decisions. Next, you'll learn how to use the Multiplicative Thinking Framework, which will allow you to see your students' strengths and weaknesses, and this document will act as a map to guide you towards the target areas that you will focus your instruction on. Next, you'll learn how to use the Leveled Activities Guide, and this guide will take the assessment data and turn that data into instruction. All you need to do is look up the level, and the guide will not only tell you what materials to use, but what questioning prompts that you need to use as well. Also, you'll be receiving 2 free books today. You will also receive the Developing Skip Counting book and the Developing Fluency with Facts book. Both of these books are designed to micro-target your instruction to very specific niche skills that are missing from your student's foundation. And finally, you'll receive over 50 teaching models for demos and instruction that will play a key role in the progression and development of your students' thinking. And at the end of this webinar, I will show you where you need to go and how you will receive these free materials and resources. So here's what it would look like using the Multiplicative Thinking program in practice. Okay, you give the Multiplicative Thinking assessment, and you're going to go through and test students in a lot of different areas. You're going to receive a score for them. After you receive that score, you'll take the student progress monitoring sheet, and what you'll do is you'll go ahead and you'll record their scores, and you'll have your baseline data. After you have your baseline data, what you'll do is you'll map out their thinking on the Multiplicative Thinking framework. Okay, and We'll spend a lot of time on this later, so I don't want to get into too many details on this right now, but you're going to test your kids in a wide range of areas. Then they're going to earn a score, and then you're going to learn, okay, this is what I need to do to progress them in this area, this area, this area, and so on. Okay? And then after you have those scores, what you'll learn to do is how to use the leveled activities guide. And again, all you'll do is you'll look up the area you're working on. It could be multiplication equal groups, the students at level A or level B. This is what they need in order to progress to the next level, and so on. So this is just the basics, a real quick summary of how this works. So this is what using the multiplicative thinking program would look like in your classroom, okay? So picture this right here, all right? This would be your small group. You'd have, 5 or 6 students, and you're working with the lessons with them, and, you're using the models, you're building multiplicative thinking, you're doing, you're working with them on the levels of what they need. Also, you'd be working out the developing multiplicative thinking book with them, and if needed, the developing skip counting book. So these are the things that you're doing with your students. But what's great about this program is it doesn't just focus on the students you're working with. We're going to right now focus on the students who wouldn't be working with you and exactly what would they be doing. Because sometimes, when you're working in small groups, we sometimes just find ourselves giving our kids busy work. Well, you're going to find out how to give your kids really high quality, effective instruction when you use this program, because we're going to focus on what they're going to be doing when you're not with them. So what's great is if you have one-to-one technology, this is super easy. If you have iPads or Chromebooks, all you do is you have to just print up an answer sheet for them, and they'll work directly off their iPads with it and track their answers. If you don't have the one-to-one technology, not a big deal, because all you would do is you would just print the page for that day and then pass it out to your students too. So think about it. If you have the one-to-one technology, this is what it would look like. And if you don't have the one-to-one technology, instead of them getting the questions off of their iPad, you just have to print the actual sheet up for them. And a third way you can deliver instruction, and no one knows exactly what the fall is going to look like right now. It's July 15th of 2020, and no one knows what the fall is going to look like. But if we have to go where we're teaching from home or e-school or virtual school, these can easily be transitioned being taught over Zoom or Microsoft Teams or Google Meet. And all you do is just do the lesson, share your screen with them, and then teach them that way. And then to push out the work, whether you're using Google Classroom or Schoology or Seesaw, you could just push out the work that way too. So there's a lot of flexibility. This is a great tool to use in person. It's a really good tool to use from teleconference too. So hopefully we're not using it from teleconference, but it is available and you are able to instruct that way. So now what we're going to do is we're going to take a look at the component now of this program, what students are doing when they are not working with you. So you have a group working with you, and then this would be the independent work that your students are doing when they're not with you. So what we're going to do now, we're going to get into, I want you to see what a lot of these resources look like. Remember, this is just a snippet. Some of this may seem confusing now, but as you learn more about the assessment, how to use the assessment and the materials, this will really start to get a flow with it. So the way that this is set up is that it is set up into different categories, okay? And it'll say like whatever the skill it's working on. So this would be multiplication, all levels A through D. And that means no matter what level that they score, you can go ahead and do that activity or do that set with them. And we'll show you how the answer sheets build the differentiation in, where it means that you could do the same assignment with students who have a huge range between them, okay? And then the next one would be, multiplication levels B through D and so on. This has to do with your assessment data, and once you go through the assessment data, you'll know where you're going to start, but more than likely you'll always be starting in equal groups, okay? And so for every single one of these assignments or these sets, there are going to be answer sheets, and the answer sheets will have the level at the top. Now we're going to take a look at what the first assignment looked like for a student who's level A or level AA. And remember, all that means is that they either aren't able to get a total or they are counting everything by one. So the goal is to change their thinking, to expose them to a different way of thinking, so they're not just counting by one, so they start to think in groups. If you think about like Vygotsky in the zone of proximal development, what we're doing, we're making a slight change with assistance to what his tested level is to get him to where we want them to be. So remember, this is what the first, there are 6 questions in each set of problems that you're going to do with your students. And so again, we're going to take a look right here. Remember level A or level A, these are students who are trying to count everything by ones. Anything about Vygotsky, what we're trying to do is get in that zone of proximal development, find out where they're thinking at, and give them slight assistance to help them to learn a better strategy, start thinking about it in a multiplicative way. So if we take a look right here, there are blank groups of blank. Well, we know that there are 4 groups of 3, and there's our groups right there. We have 4 groups of 3. And now the next thing, it's going to say repeated addition problem, 3 plus 3 plus 3 plus 3. And the last part, and this is to teach them the value of that, because skip counting is such a useful tool when you're learning about multiplication and division. It gives you another strategy that you can use, is teaching them a reason or a meaning for why learning skip count by more than just 2s, 5s, and 10s can really help and assist them. So this is where you can give them practice at skip counting instead of, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, where they could go, 3, 6, 9, 12. Now notice for level A or level AA, there is no having them write a multiplication equation, because we're not there yet. That's not what our goal or what we want to do is. So now what we're going to do is we're going to take a look at this. This is the same exact problem, but take a look. The answer sheet has been changed to a student who scored at a level D. So we're asking them to do completely different things. As for level A, the whole goal was to look at it in groups. Now, if you take a look at level D, we're doing a lot more. So the first one says they have to look at this and write a missing factor equation. So they have to they get to pick. You can have them say you don't know the groups, the number in each group, and then you're going to write an equation. This is because we're getting them ready for division. And kids have to be able to do missing factor or find a missing product in a multiplication equation in order to transfer their thinking over to division. And then you go ahead and have them go ahead and write the multiplication equation right there. And then this one right here where it says one more group. If there was another group, we wouldn't have 4 groups, we would have 5 groups of 3. So again, this was the same. You could have the same students looking at the exact same models or doing the same sets, but your expectations, what you're asking them to do, are 2 completely different things. Okay. Now, if we're going to take a look, I'm just going to show you a different one. If you take a look right here, we're going to go ahead and say, well, what if you are working on multiplication levels B through D? This is just equal groups with partially screened models. So instead of the models being able to see everything, there's going to be a partial screen to it. Okay. So again, here's what we have right here. We have a model, it's screened. We're not going to be able to count all of them, and that's fine. And remember, for a student who's a level B, what are they doing? They're adding or they're skip counting, right? They're not putting it into a multiplication equation. So if you take a look right here, what we're doing is that we're having them focus in on the groups, right? 5 groups of 5, which is that what essentially they were focusing on the groups number in each group because they're doing repeated addition or skip counting. Now what we're doing is we're having them connect that to a multiplication equation. So the slight change we're doing is we're saying, all right, you're thinking in groups, but now we want you to think in taking those groups and forming a multiplication equation. So that's just another example of the slight changes between the levels and what you're asking your students to do. All right, now if you take a look here, we're going to go ahead and just show you sort of the range of this too, where it says multiplication missing factor level D. Now this is all about getting your students ready for division, and you'll see once you go through the rest of the webinar, it will make sense what we're trying to do here and what the goal is. But if you take a look, a student will come across a problem like this. They'll say 25 apples into groups of 5. How many groups? Now again, the missing factor equation, we don't know how many groups there are, but we do know that there's 5 in each groups. So they would go ahead and write. They don't know how many groups, but but there's 5 in each group. Okay. And again, now writing the multiplication equation would be 5 times 5 equals 25. And then the last one, again, having them go through and do that. What's really important about this is where we're really starting to focus in on division, because the next set that they'll be doing is they'll be going directly into division. Now, remember, they didn't have to write 25 divided by 5. They're still thinking as this is a multiplication type equation. Okay. Now, for the next set, we're going to go up here, we're going to go into the division models now. Remember, your students have gone through their equal groups and equal groups screen. They've gone through the equal groups algebraic models. So take a look when you get into the division models right here. Now, the main difference between these division models and the missing factor ones or the ones for algebraic thinking is this. It's specifically going to say 30 apples divided into groups of 6. how many groups. So the word divided, the other one didn't use the word divided. It would just give you a model with the missing information. So now it's encouraging them to think in terms of division. Okay, so we take a this one, it says 30 apples divided into groups of 6. And the first one says, it says product first, missing factor equation. So we're so used to kids writing, and here's why you're writing product first. We usually write, something, or 5 times 6 equals 30. We're saying 30 equals, we don't know how many groups there are, so we're leaving that blank, but we know that there's 6 in each group. And then what we're teaching them to do is understand that relationship, right? When you're thinking about that 30, it's 6 times something equals 30. That's there. So when you go ahead and you say 30 divided by 6, it's the same type of thinking. You're saying 6 times what number equals 30, and we know that the answer would be 5. So that's a big thing. It's slowly scaffolding. And again, if you go back to Vygotsky, this is what we're really talking about, the zone of proximal development. We're slowly scaffolding, making small changes. We're encouraging different types of thinking to our end goal, and our end goal is to teach them to be multiplicative thinkers. And again, the last part of this is with the range of this too, we're not going to get in, but there's simple story problems and there's more complex story problems too. So depending on what grade level you're in, we can go ahead and we'll take a look at this. It says Thomas has 6 boxes full of baseball cards. Each box has 56 cards. How many baseball cards total did Thomas have? So again, whether you teach your students use sort of that place value sections method or teaching them to go ahead and use like a standard algorithm, whatever way you want them to solve or practice can be used on this. It doesn't have to be, it's your methodology or what strategies you want to use is really up to you how you want them to solve it. But this provides you still just some more practice that you can have with your students. What is multiplicative thinking? What is multiplicative thinking? So now what we're going to do is we're going to watch 6 students. 4 students are going to solve a multiplication problem and 2 students are going to solve a division problem. And as you're watching these next 2 slides, think about, as their teacher, what would you do specifically to help each one of these students? Okay, how'd you get that answer?
Because I just added all of these. I just counted all of these.
So like, show me what you were doing, what you were saying in your head.
I was counting 1 by 1.
Okay.
36.
Okay, how did you get that?
I did 6 plus 6 plus 6 plus 6 plus 6 plus 6.
So you just kept adding 6 and adding 6 and adding 6? Okay. How many cans of soda are there?
36.
And how'd you figure that out?
I will. 6, 12, 18, 24.
Alright. Now, how many cans of soda are there total?
36.
How did you figure that answer out?
I counted one group of the cans and they had 6, and then I just did 6 times 6.
Okay.
That's apples again.
There are 21 total apples. I want you to even divide them into 3 boxes. How many apples are in each box?
I don't know how many I'm going to put there. This one's tricky. This one's hard.
We're gonna go next.
There are 21 total apples. I want you to evenly divide them into 3 boxes. How many apples are in each box?
7.
How'd you figure that one out?
Because 21 divided by 3 is 7.
So is the difference that some students were fluent with their facts and others were not? So that thought had to have popped into a lot of people's heads as you watch those first few clips. And some teachers may say, well, these kids can fall into 2 categories, those who know their facts and those who don't. So what some teachers would do is say, okay, well, what we need to do is strengthen their facts. So I'm going to put them on Math Facts in a Flash, or have them work on multiplication.com, or put them on extra math. So we're going to take a look now at some students and look at a student and get a little bit more information and see if Math Facts would be an effective intervention or an effective strategy for her. So what you're about to watch right now is a student, and she is being administered the multiplicative thinking assessment. This is just a small part, and she's going to be asked a question, okay? And then it's going to look like it's going to do a flashback. There's going to be a division problem up there, or a multiplicative situation division problem. Then it's going to flash back to about 10 minutes earlier, where she was just given raw facts, and we're going to see her if she can solve the math fact, and then it's going to go back to see if she can apply the math fact to the situation that she's in. And the next slide is going to do the exact same thing. It's going to present her a problem, then it's going to show her doing a math fact, and it's going to flash back. So it'll make more sense once you watch it right now. The man has 24 cookies. He put 6 cookies in a bag. How many bags does he need?
4. So he has 24 cookies?
There's 24 cookies, and he's going to put 6 in each bag, 6 in a bag. How many bags would he need?
So 25, so there's...
You can go up there if you have to.
Okay, there's 6, or I don't know what to count by, or do you have to skip count?
Well, your strategy is up to you, but so there's 24 cookies, and he's going to put 6 cookies in a bag. But how many bags would he need?
So 6 cookies in each bag, 3, 6, 9. I'm counting like this, 3, 6, 9, 12. Or now that would make sense.
Well, so again, I'll ask it one more time. So there's 24 cookies, and he's going to put 6 cookies in a bag. So how many bags is he going to need to put all those cookies away?
So 6.
6 bags? Okay. All right. There are 21 total apples. I want you to evenly divide them into 3 boxes. How many apples are in each box?
3, 6, 9, 12, 7.
Okay.
How many apples?
So there's 21 apples, and then we want to put it equally into those 3 boxes.
Okay, so I don't get this. So are you like? So there's 24 apples.
Actually, how many apples does it say there are?
I mean 21 apples.
There's 21 apples, and so they have to be split evenly in those 3 boxes. So there's none in those boxes yet. We have to put them in the boxes.
So slide them in there?
Well, we're not going to be able to slide them in there because it's not. So that 21 means those apples. So we know there's going to be 3 groups, right? Or 3 boxes.
Yeah.
So how many would go in each box if we did it evenly?
9.
9. And how'd you get 9?
I just said 3, 6, 9.
Okay.
Because
Okay.
I just skip counting is easier now.
Skip counting works easy for you? Good. So think about what we just watched, right? Now, was she 100% fluent with her facts? No, but she was pretty efficient. She understood what she was supposed to do with the math fact. She was able to get an answer within like 2 or 3 seconds of it. So think about if you just have if you were just to focus on math facts for those students, would that really be helping them? Would that really be strengthening their foundation and having them, giving them exactly what they needed? Because many teachers would have seen the first few clips and would have said, well, it's easy. Those last two students that were able to come up with a fact, they knew their facts, the other ones didn't. So what I'm going to do is I'm going to have all my students work on their math facts. That's kind of the thinking a lot of people would think after seeing those first few clips. So now we're going to reference back to the primary numeracy webinar, and as this webinar goes on, you're going to see this really is just an extension of the K through 2 one. So I wanted you to think about right now the progression of arithmetic strategies. That's something we went through and spent a lot of time with in the primary webinar. Okay, so picture this. We're talking about, math facts, right? And whether you're teaching math facts for addition, subtraction, or you're teaching math facts for multiplication, division, you have to understand is that children go through different stages of development, right? There's a progression of arithmetic strategies. There's a progression of multiplicative thinking. We're going to focus right now on the arithmetic strategies. Next slide, we will deal with the multiplicative thinking. But if you have a student who's in the perceptual understanding stage of counting, right? But your curriculum, your goal is for them to work at that facile, flexible strategies. And think about what perceptual is. Perceptual means that they need to either use their fingers to count everything, or they need counters and they have to see it, they have to touch it, they have to count from one, right? And so if you just take a student, you say, okay, you're at this perceptual stage, but what we're going to do is we're going to work on the Make 10 strategy. That's too big of a gap. And if you remember the primary numeracy framework, perceptual thinking is there. The Make 10 strategy is there. There's a ton of curriculum and a ton of things that need to be in place before you can even get to a student to have the skills to even be able to do that type of problem solving. So if you just say, okay, we're going to start working on these problems right here, and you're going to learn at this very high level, they don't have the background, the foundation to be able to do it. So if you viewed the primary numeracy webinar, you'll be very familiar with the primary numeracy framework. And what this is two things. One, it's your curriculum standards, but the other is when you're done, you are able to use this to map out each student's thinking. So you'll know exactly where their level of development is, how they're thinking, where they're at on the curriculum. And what today is really just an extension of the primary numeracy webinar, where the primary numeracy framework has evolved into the multiplicative thinking framework. And again, it's the same style, right? You're going to test your kids in different areas. You're going to receive a score. Each score is going to represent a level of thinking. And then what you'll be able to do is take that data and create lessons to help move them from level to level to level. So now we're going to talk about the progression of additive to multiplicative thinking. And just as we learned in the primary numeracy webinar about the progression of strategies that students have with arithmetic strategies or addition strategies and subtraction strategies, this follows the same type of thing. If you think about Vygotsky and the zone of proximal development taking you back to undergraduate education classes, this is figuring out what a student can do and how they're thinking independently, and then the small changes that we can do or what they can do with assistance. And that's what this progression really is finding out where a student is and then trying to teach just slightly above and giving them assistance to kind of change the way that they're thinking. So multiplicative thinking is the capacity to work flexibly and efficiently with the concepts, strategies, and representations of multiplication, division as they occur in a wide range of contexts. This goes well beyond memorization of basic facts. And remember what we saw with that girl earlier on. She had some knowledge of basic facts, but was not able to really apply it in a situation when she needed it. You can discover what type of thinking a child is doing by focusing on what the child says and does rather than if they succeed on a particular task. It is about the structure the child imposes on the problem, not the structure inherent in the problem. They do not always see things the same way we do. So when we'll present students with a problem that's obvious to us that it may be like 6 times 4, they're not seeing it that way, and a lot of teachers have a tough understanding of, well, why aren't they seeing it when it's so blatantly obvious to me? Multiplicative thinking cannot be generalized in any simple way from additive thinking. Unless teachers consciously help students develop multiplicative thinking, it may not happen for some children. Additive strategies can disguise themselves as multiplicative understanding if teachers are not paying close attention. And lastly, multiplicative thinking takes years to develop and extends to place value, percentages, scale, proportions, rate, ratios, arrays, division, fractions, decimals, etc. The development goes well beyond 3rd and 4th grade year. And if you take a look at for a student who is in that sort of counting one-to-one, or that's their strategy they're relying on, and you think about what we really want is that multiplicative relations, or that flexible multiplicative reasoning, it's such a jump to try to teach a student at that multiplicative relations level when they're thinking at such a basic level. So again, when we talked about what the framework does and what the framework is designed to do, and again, we talked a little bit about Vygotsky and that zone of proximal development. What this really does is it helps us narrow down and find a student's thinking, and then we're able to see the small changes in instruction we need to do to progress the student, because it's just too much of a jump for a student to go from level A all the way to level D, because there's several stages of thinking and understanding that have to occur before a student can really be in that deep level of understanding. So after that quick overview, now what we're going to do is we're going to look at the misconnections from the primary grades and see how it directly affects concepts in the upper grades. And one of the misconnections or basic skills that are missing that a lot of students have is they don't understand the relationship between addition and subtraction. So here's a good example of this. If you're asked, students, what's 100 minus 3? Most students will be able to say, well, it's 97. They go 100, 99, 98, 97. If you ask those same students, what's 100 minus 97? Students who understand the relationship of addition subtraction, they would just go, 97, 98, 99, 100. They understand sort of the part-whole relationship that 97 is part of 100, and they just count their way up. For students who don't understand the relationship of addition subtraction, they're going to go ahead and do something like this, go back to that algorithm, right? And you'll see this, and when I first started my career, I taught 4th grade. I always thought, why do they do this? Why don't they just do it this way? It's because they don't understand that relationship. So think about this. If you don't understand the relationship between addition and subtraction, think how much more complex that relationship is for multiplication and division. When fact families become a process procedure. Now, we talked about the relationship of addition subtraction and the relationship of multiplication division. And most of the time when we're trying to teach the relationship of addition subtraction or multiplication division, we do it through fact families, right? So here's a successful fact family right here, right? 8 and 7 is 15, 7 and 8 is 15, 15 minus 8, 7 is 8, and 15 minus 8 equals 7. Okay. Well, when kids are working on fact families, a lot of times, especially if you ever taught 2nd grade or 1st or 2nd, and even sometimes 3rd grade, when going through, sometimes students will produce, fact families like this. So as teachers, what do? We say, okay, for subtraction, remember the bigger number always goes first. Addition, small numbers make the big numbers. So that's sort of our thinking. We think we're helping them. So what we've done is instead of them, learning about part-whole relationship and, discovering fact families through a more natural way, we proceduralize it. We make it very procedural. Now take a look right here. What we have right here is 8 times 7 is 56, 7 times 8 is 56. 8 times 56 divided by 7 is 8, and 56 divided by 8 is 7. That's a perfect fact family. Again, if you taught 3rd or 4th grade, what you'll realize or what you'll understand is students, you'll see this a lot of times too. So what do we do as teachers? Well, when dividing, the bigger number goes first. In multiplication, small numbers make the big number. And so again, what we've done is what we're trying to do is we're trying to give them a tip, something that will help them make sense. But what we've really done is something that should be a very natural development, we've turned into a process and procedure. So multiplication division. As with many basic terms of mathematics, there's a commonly held belief that there is an understanding that we have when we refer to multiplication division. If pressed for a definition, the idea commonly offered is that multiplication is repeated addition, which would mean that division is repeated subtraction. The idea of multiplication as repeated addition is not far from the mark and can be a useful way of thinking about multiplying whole numbers. However, division problems rarely encourage the use of repeated subtraction. The different styles of division questions encountered emphasizes the identification and use of the relationship of the multiplicative, multiplier, and product. Sometimes we are interested in how many are in each group, and other times we want to know how many groups there are. Finding the answer involves the ability to manage and understand the relationship of these groups. And multiplication can equally be described in terms of group. Learning multiplication and division is described as managing groups as units. The progression of increasing sophistication in identification coordination of units in multiplication and division is a key to developing multiplicative reasoning. Okay, so when you think about how multiplication division is currently taught in a lot of classrooms, it usually follows this type of process. So students will learn their multiplication facts, and this is how I learned as a student. So students will learn their multiplication facts and learn the commutative property. And then you'll hear teachers say, well, if they know their multiplication facts, they know their division facts, which is not actually true. If you know your multiplication facts, you have a means or a way to solve your division facts, but it doesn't necessarily mean you understand division facts or know how to use them. But the progression right now is learn your math facts, and then through some rearranging, we teach you your division facts. But what research has shown is that children go through 3 different stages when they're learning the relationship between multiplication and division. And the first we're sort of spot on with. We do a really good job with that, and that is making sure that they have the commutative property. The second one says students can use a known fact to solve a missing number task. For example, if they know 5 times 7 equals 35, they can use this fact to solve something like 5 times 35. Or something times 7 equals 35. And the last one says they can recognize the relationship between multiplication and division. So this is a good explanation, but there's not a lot of meaning. It's just showing equations and equations with missing factors. So now what we're going to do, we're going to take a look at what that development would look like in like a real life situation. So for every multiplication problem, some people are not aware of this, there are 2 types of division problems that can be created out of that one multiplication problem. And going through this progression is key to kids understanding the inverse relationship between multiplication and division. So let's take a look. Jean has 4 tomato plants. There are 6 tomatoes on each plant. How many tomatoes are there all together? And we know that that is 4 times 6. 4 groups of 6 equals 24. Jean has some tomato plants. There are 6 tomatoes on each plant. Altogether, there are 24 tomatoes. How many tomato plants does he have? Measurement division refers to you're solving for how many groups. You know how many are in each group, but you don't know how many groups. So when you go through that, you'd basically be looking at as, I don't know how many groups, but I know there's 6 in each group equals 24, or you could look at it as 24 divided by 6. Understanding this transition to this is really, really important to doing that. And that's often a missing step that we do. And then the last one, partitive division. Partitive means we know how many groups, but we don't know how many go in each group. So Jean has 4 tomato plants. That would be our groups. There are the same number of tomatoes in each plant. Altogether, we have 20 tomatoes. How many tomatoes are there on each tomato plant? And again, this one's different because we know our groups. 4 groups times, we don't know how many in each group, equal 24, or 24 divided by 4. And what's important to understand too is when you're building this foundation, not too long after they learn about this, they'll be doing problems such as, okay, 4 times 1/2. A lot of kids don't understand that the rules of multiplication still apply. Oh, that's 4 groups of 1/2. So if I have 4 groups of 1/2, what does that equal? That equals 2. That explains, oh, I'm multiplying. I'm ending up with less with what I started because you're going, a half, a half, a half, a half. And this one's saying, okay, I don't know how many groups, but if I multiply it by a half equals 2. And again, 4 times something would equal 2. And so it's important that students understand the relationship between multiplication and division, so when they get to rational numbers, they can still use the fundamentals that are in place for when they're doing it. Often this just becomes, memorize the process, and I've heard teachers say, multiplying, dividing fractions is easy. And it's the process is easy, the procedure is easy, but explaining what's actually happening is very difficult. A child has to fully understand multiplication before they can understand division. Research shows that multiplication and division should be taught simultaneously. However, students have to have a certain level of understanding and thinking before that process can occur. So just teaching multiplication and division, though, that is the best practice, teaching it simultaneously or together is the best practice. Students still have to have an understanding of what multiplication is. If a child has a very, very low level of multiplicative thinking and doesn't really understand what multiplication is, it's going to be very, very difficult for them to even understand that bridge to division. Though multiplication and division are the inverse relationship of each other, they have to have a clear understanding of multiplication first before they can even understand that inverse relationship. So what we're going to do now is the multiplicative thinking framework. What this is these are all about different thinking levels, and we're going to go in great detail in this in a few minutes. We'll go into great detail about the thinking levels and what they are and what needs to be done at each level and so on. But the main problem of what's wrong with our curriculum right now is if you take a look at this framework, it has level A, and don't worry about what level A is or level A or B or C or D. That's not really important right now. What's important is that the instruction, our standards, are written at a very high level, okay? And even though we may have students who are performing at a lower level, what happens is our math books are not even accounting for students who are thinking at that low level. And all of our standards are really, and which is what you want, our standards are at a very high level, right? But they're at such a high level, it doesn't account for students who are not ready to be thinking at that level. So the instruction just basically cuts out a huge chunk of kids. And it just says, well, this is the standard, this is how they're supposed to be thinking. And what we know is kids who don't have the background or the strong foundation are not going to be able to work at all those standards. And so those are the actual standards that go along with the thinking levels. And level D, you're going to hear a lot about level D today. That's the highest level of where you're supposed to be. And all that really means is you're performing where your standard or student is performing exactly where their standards say they should be. Okay? And we'll spend more time going through what this framework looks like, what everything is on it, and everything that's designed for it. So partitive and measurement division. So these two types of division questions are described as partitive division and measurement division. And measurement sometimes is called quotative division. Partitive division refers to dividing a whole into several equal parts, right? Knowing how many groups there are, such as sharing 12 cupcakes equally among 4 people. Partitive division arises from the notion of sharing or distributing equally into a specified number of parts. Measurement or quotative interpretation division determines, for example, how many units the size of 4 are contained in the composite unit of 12, a measurement notion. Thus, measurement division refers to dividing a whole into a group of a certain number of elements, such as there are 12 cupcakes and each child gets 4 cupcakes. How many are there altogether? So when visualizing, taking a look, partitive division, we know exactly how many parts there are, right? Partitive, how many parts or groups there are. Measurement, we're trying to figure out how many of these 4s will fit into that. So what we're going to go through now is we're going to go through, for every multiplication problem, a measurement division problem can be made and a partitive division problem can be made. And this is important because if you're going to develop the relationship or the inverse relationship between multiplication and division, it needs to go through these progressions, okay? And so we'll take a look and we'll go through multiplicative groups, multiplication and equal groups, measurement division, and partitive division. And then we'll go through and take a look at what the direct modeling looks like, and then we'll look at the problem structure. And you'll see why some problems are easier for students, why some problems are harder for students. But the important part is, remember, this is all about teaching about the management of groups, right? So when our students are solving a multiplication problem or division problem or partitive division, they won't even really be thinking about, what am I dividing? Am I multiplying? What am I doing? All right? So multiplication equal groups. Mark has 4 bags of apples. There are 5 apples in each bag. How many apples does Mark have altogether? And again, for us, we immediately would say, well, 4 groups of 5 equals 20. We're multiplicative thinkers, and that is how we'd solve that, right? Now, measurement division. Remember, measurement division means you know how many are in each group. You just don't know how many groups you have. So Mark has 20 apples. He puts them in bags with 5 apples in each bag. How many bags did he use? And for us, we just say, okay, 20 divided by 5 equals 4. Again, no problems with that. In partitive division, right? Mark has 20 apples. He wants to put them equally into 5 baskets. How many apples will each basket have? Again, for us, it doesn't matter if we're solving for how many groups or how many in each group. Because we're multiplicative thinkers. We understand the relationship between all these numbers. We understand how to manage these groups. So it doesn't matter to us, okay? But you're going to see now for students who don't have, command of their math facts, and command doesn't just mean knows your math facts, but command knows how to apply them in multiplicative situations, and they don't understand how to manage groups or the relationship between the factors in the product. You're going to see how the direct modeling works, and then how the problem structure works, and why some of these cause a lot of problems for students. So let's take a look at the direct modeling, right? So say a child doesn't know it's 4 times 5, right? Well, we'd say, okay, direct modeling, well, there's 4 bags with 5 apples in each bag. So I say, okay, there's 1 group of 5, 2 groups of 5, 3 groups of 5, 4 groups of 5. If you direct model exactly what the problem tells you, that's what you get. And you get, 5 plus 5 plus 5 plus 5, or 5, 10, 15, 20, okay? For measurement division now, let's take a look. Ready? You have 20 apples, right? And it says he puts them in bags with 5 in each bag. So what we can do is we can measure our way. Or we can measure our way from 20 back to 0, or we can measure our way from 0 up to 20. But what we're saying is, okay, we have 20, and we're going to say, okay, group of 5. So I have 1 group of 5, 2 groups of 5, 3 groups of 5, 4 groups of 5. So our answer through direct modeling, we could go ahead and follow exactly what it tells us to do, and our problem and our answer be 4 groups of 5. Okay. Now, part of division where this is difficult and different. Okay. The direct modeling. So as for measurement division, right? We started with 20, and we were just going to go ahead and start, using 5 until we ran out. This is different. So it's saying Mark has 20 apples. He wants to put them equally into 5 baskets. So there's our 5 groups, right? But we don't know. There's no clue as to how many will go in each basket. If we don't understand the relationship between this 20, the 5, and the 4, we have 2 strategies we can use, and both of these strategies are really low and inefficient strategies. The first one is we can go ahead and say, well, I'm going to go ahead and do my 5 groups. I'm going to use trial and error. Okay, I'm going to put a 3 here. 3, 6, 9, 12, 15. Nope, 3 didn't work. How about 2? 2, 4, 6, 8, 10. Nope, that didn't work either. Think about how inefficient that strategy is. And again, for us, this is easy because we understand the relationship between 20, 5, and 4. For a student who's learning about this, about the management of groups, this is not something that they're going to be able to do. So they have to think, all right, well, what would I do now? The only strategy, what part of division encourages, either trial and error or, ready, 1 for you, 1 for you, 1 for you, 1 for you, and 1 for you. And what we'll do, we'll keep doing this until we deplete 20 and run out, okay? Again, 1 for you, 1 for you, 1 for you, and 1 for you, 1 for you, 1 for you. So think about just how with multiplication it was okay. Think about with multiplication, it was groups of 5, and we had no problems with it, right? Think about with measurement division, again, it was groups of 5. And think about part of division, it encouraged a really low level of thinking. So let's take a look at the problem structure. Say a child wasn't going to use direct modeling. Say they were going to try and use the problem structure. They could go 5 plus 5 plus 5 plus 5, which equals 20, right? And 5, 10, 15, 20. But what are they counting by? That 5 means 5 apples. So they're actually counting by, I would like to say, they're counting by what they're solving for. They're solving for how many apples are there. They're counting by apples, okay? And they're dividing the apples, all right? Now, take a look at this one right here. This problem, if you think about it, when we had all the 20 here and we took 5 and 5 and 5, this would be one of the times where repeated subtraction would be an appropriate method. I'm not saying they should do it that way. I'm just saying if you follow what we did, we had 20 and took 5, 5, 5 and got 0. Or you could work from 0 and go 5, 10, 15, 20. Regardless, guess what? What do you skip counting by? You're skip counting by apples. Now let's take a look at this one now. Now remember, for direct modeling, we either had trial and error, which we know is not a good strategy, or 1 for you, 1 for you, 1 for you, 1 for you. So think about that, -1, -1, -1, -1. Think about what a low level of thinking, a low strategy that is. You may be saying, well, wait a second. Up here, all we did is we just skip counted by 5, right? And we subtracted by 5 or skip counted, and that's what we did. Here's why this is more difficult, because when you know how many groups, this 5 does not mean apples. This 5 means baskets. So imagine being a student who's learning about this. You don't understand the relationship between 25 and 4, right? And so to say, okay, all you're going to do is you're going to skip count by 5 up to 20. Go 5, 10, 15, 20, right? And you're going to get 4. It doesn't make sense. And why would they be skip counting by the baskets, right? That doesn't make sense. So I just skip count by the baskets, and then that's going to be my answer. So what you'd have to do to say if you're going to skip count by 5, you have to actually change the meaning of what the 5 means, okay? Here's what the 5 means. Ready? If you're going to switch it and say, okay, we're going to go by 5, you're going to say, all right, I'm going to give 5 away, but everybody gets 1, okay? So every time I get rid of 5, it means everybody gets 1. So it's almost like we've unitized it. And when I give away the next 5, that means everybody's going to get 2. And then when I give away the next 5, it means everyone's going to get 3. And the next 5, everyone's going to get 4. So every time you lose 5, it means everybody's getting 1. That's very concrete. That's very, very difficult. That's very, very, very hard for students to understand that. And that is why, this is how you teach the management of groups, teaching students about the multiplication equation, the measurement division, the partitive division.
205 muffins, she put them in boxes of 4 each. How am I going to complete this bar? 205 on top, right? The whole way is 205. And the question, I guess, is what does the 4 represent? Are there 4 boxes? Or does 4 go in each box? Yeah, she put them in boxes of 4 each. So there's 4 muffins in each box. A little dot, 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 question mark action there to denote that we don't know how many boxes fill up the whole bar. So if this is our picture, are we looking at partitive or measurement division? Yeah, if we know the measure of the size of each box or part, then that is measurement. Okay. 5 packets of ground coffee weigh 750 grams. How much does each packet weigh? Again, I'm going to start it with a box. I'm only going to get it started with the 750 being the whole way. The question is, what does the 5 represent? Number of boxes or size of each box? Next, we have 5 packets, right? So each little box represents a packet. And then we don't know how much each packet weighs. That's our question mark. We know the number of parts, partitive division, right? A man has 316 oranges. He puts 3 oranges in a bag. So the 3 represents the number of parts or the size of each part? Size of each part, right? He puts 3 oranges in each bag. We don't know how many bags fill up the whole way. Measurement or partitive? Measurement, right? We know the size or the measure of each part.
So what we'll be doing now is we'll be going through the multiplicative thinking framework. And what we're going to do is we will take a look at what every level for each, for multiplication, equal groups, division, measurement, imperative, extending multiplication, rate multiplicative comparison, multiplicative connections, and multiplying multiples of 10. We're going to go through each of those levels, so you're going to actually see students what they look like at each level. And also what we'll do is after we see what students are at each level, we'll go through the the leveled activities guide and go through the different activities that you can do too. So remember, you get a ton of resources with this, and these are all the things that you can do with the resources that you received. So what we're going to do now is we're going to take a look at the levels, okay? Because when we get into the framework, there's going to be a level A, B, C, and D. You need to understand that for every level, there's actually a higher side of a level and a lower part of the level. And so we're going to go through what that is. But if you take a look at sort of how it evolves, it starts off with there's counting, and level A represents some type of counting, right? Level B is additive composition and counts many to 1, also known as repeated addition and skip counting. And remember, B, there's a lower part, which would be additive composition. There's a higher part, counts many to 1. We're going to go level D is flexible multiplicative reasoning, which is, when students just are, using math facts connected to multiplicative situations. And then level C means that they rotate. They may do some problems at level D. They may drop back and use additive composition or counts many to 1. Okay. And so now we're going to kind of go through. And when you take a look at the assessment, this is what one of the scoring looks like in flexible multiplicative thinking, as flexible multiplicative reasoning. And then it says skip counts and repeated addition. Just remember, additive composition is the same thing as repeated addition, and skip counting is counts many to one. The reason why this is easier for teachers to understand, this is the research that was used. Use these terms: additive composition, counts many to one, rhythmic counting, stress counting, and so on. So someone didn't have to have, a math PhD to give this. We use, okay, skip counting, repeated addition, stress counting, counting by ones. So that's just why it looks different, but it means the same thing. So if you take a look at level A, again, level A, you'll see what stress counting looks like. It represents some type of counting, right? Level B means they're using repeated addition, or they're using skip counting, or a mix of those skip count then additive composition. Level D means they're tying math facts to what they're working on, and they're able to solve it quickly. And then level C means they kind of go back and forth between level B and level D. And remember, when you give the assessment, this is what the scoring sheet will look like. In about 45 minutes, I'll say, we'll be giving the assessment, and then you'll have a chance to actually see what the assessment looks like. And this is an example of what stress counting looks like.
Now they're arranged in threes, aren't they? Could you show me how you'd count those counters? You can move them if you'd like to.
3, 6.
She's counting by ones, but emphasizing the multiple.
9, 12, 15.
Thank you.
Okay, so we're going to go through now. We're going to go through the multiplication equal group part. We'll be focusing right here. Remember, today we'll go through each one of these, and we'll get to see what students look like, what these, what the questions look like, and this will help us understand what the different levels are. So right now we're going to go through what level A is. And level A, if you remember from a few slides ago, level A represents some type of counting by ones. So it says student counts 1 to 1 when presented with an equal groups problem. To progress, they need to begin to identify the number of groups, how many are in each group, and without being prompted. If there were 4 tables in a room that looked like this, how many people would there be? So there's 4 tables that have that number of people in a room.
So just add like 3, act like there's 3 more tables or 4 more.
Well, so there's 4 tables that look exactly like that. So it'd be 4 total tables like that. And remember, she can skip count by 5s because we tested her earlier and she proved she could skip count by 5s, which many kids could. But she has a perfect situation to apply that, and she's not.
Because I counted all the people, and then I was thinking 4 more tables, and then I counted the people again, and then I acted like there was more people, and I started counting.
Okay, how did you count?
I counted like just once.
Okay. How many dots are there in the array?
In their array?
How many dots are there in this array right here?
20.
And how'd you get that?
I just counted.
Okay. And what'd you count by?
I count by ones.
Okay. And so for characteristics of students at level A, grouping does not make sense. They do not realize that skip counting will give them the same total as counting by ones, even if they know the skip counting pattern. Again, most kids can skip count by 2s, 5s, and 10s. And even when they were given ones that had 2s, 5s, or 10s, they still counted by ones. Does not see the count as a permanent indicator of the quantity of the collection. They do not trust the count. Even if they know that they're going to have, like, there's 4 people at the table, and then there's another 4 and another 4, they don't trust the count, so they go back. The count that they do trust, they trust the count by 1. May be able to make groups to represent a multiplicative situation, however they count from the beginning in order to find out how many. So for example, if a student who's thinking at level A was given a story problem, this is what it would look like. So there are 4 buckets with 5 apples in each bucket. How many apples are there altogether? Write an equation. So they go ahead, all right, 1 group, 2 groups, 3 groups, 4 groups, there's my buckets. Then they're gonna go ahead and put those in there, and then they're gonna go ahead and go, okay, ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So they're going to solve it counting by ones. Now, as a teacher may go through and look at this and say, wow, they really showed they understand multiplication. But all they did was just make a giant set and just count from 1. So even though it may have shown that, you know, it may look like they understand multiplication, they're actually using a really low-level strategy of counting by ones. And then we look at this and say, well, oh, they understand multiplication. They know how to make the groups, but they're not doing any type of multiplicative thinking to solve this. And then at the end, we may say, okay, go ahead and write an equation. And then they're almost like programmed, like, oh yeah, when I'm all done, I'm going to write an equation, but think they didn't even use this equation at all. So if you take a look right here, and what it says is, even though there's a clear structure to this situation, she's viewing it like this, okay? A grouping of unconnected and unrelated ones. The only type of count she trusts is the count by 1. So even though, you know, I'm not saying this is exactly how she's seeing it, but she's treating it just like this, okay? A collection of unconnected ones with no groups, okay? And for this one right here, it says, data from earlier showed she can orally skip count by 5s. However, when given an opportunity to apply skip counting to be more efficient in a multiplicative situation, she chose to count by 1s. So again, she can count by 5s, but she's not using it. So she's being, you know, why is she not using it? Because she's not making a multiplicative connection to that situation. And again, even for this one right here, her data showed she can't skip count by 6. But, you know, a more efficient, higher level strategy just be for her to add these 6, you know, 7, 8, 9, 10, 11, 12, 13, 14, to go ahead and that. But she didn't even try to use repeated addition. She just counted everything by ones. So instructionally, this is what you would do. So this is what the leveled activities guide looks like, or this is just a clip of it for levels A. And remember, level A means that they weren't even able to do it. Level A means they're counting by ones. So this is the types of things that you would do with them, okay? So the first one is you would show them equal groups models and array models. And remember, how many groups are there? How many in each group? Write a repeated addition problem. Can you skip count to find the total? Your goals for level A or level AA are really easy. The first goal is you want them to start to identify groups and how many are in each group. Next, you want them to connect it to addition. And the third one is create a reason for skip counting, okay? And they may not be able to know how to skip count by all these, but you want them to learn, wow, look, if you can skip count, this is much more efficient than if you are just counting everything by ones. So for the array, too, I want to show you this. For the array, when kids are working with arrays, it's just like reading. You read from left to right, and then you sweep back with your eyes. So this would be 1 group, 2 groups, 3 groups, 4 groups. So left to right, sweep with your 1 group, 2 groups, 3 groups. And again, have them work that way. Okay, another one's the part-whole model. And this is a good model, very important when developing division. But you let them, they can see the answer, which is 18. They can see the groups, and they can see the number in each group. So again, how many groups are there? There's 3 groups. How many in each group? 6. Write a repeated addition problem, 6 plus 6 plus 6. Can you skip count? They're not going to be able, most kids who are struggling aren't going to be able to skip count by 6. But you can say, if you were going to skip count, think how much faster it would be to go 6, 12, 18, and try to count your way through. And finally, again, equal group or pictorial cards or number cards, same thing. Your whole goal for level A is how many groups are there, how many in each group, write a repeated addition problem, can you skip count to find the total. And these last two things, these are not included in your materials, but if you have a deck of cards, or better, 2 decks of cards, which will give you up to 8 of each card, you can do the same thing. Build problems, how many groups, how many in each group, repeated addition, skip counting. That is your goal. Our goal is for them to identify groups, a number in each group, connect it to addition, and connect it to skip counting. And that is your level AA and level A instruction. And think about this. This seems so far away from those kids, but remember, these are 4th and 5th graders that we're looking at right now. And when you're in 4th grade, you're going to be asked to do a problem like this. So what making sure they understand the meaning does is, you know, a lot of times we'll just say, okay, 5 times 1/4, just multiply across and you'll get 5/4. But remember, 5 groups of 1/4, this is exactly what it would look like. 1/4, 1/4, 1/4, 1/4, 1/4, and it gives them some meaning, okay? So that's how you get 5/4, or you could say 1 1/4. But again, making sure they have that foundation of this is what equal groups is, all right? In 4th grade, and I'm not sure if this is 4th grade or 5th grade, where they have to multiply a fraction times a fraction. So we're like, think about this. 1/2 times 1/4 is 1/8, right? Well, again, half of a group of 1/4. So there's 1/4, and half of a group would look like that, and that would be what 1/8 looks like. So again, adding meaning, because sometimes I've heard teachers say, well, multiplying and dividing fractions is really easy, which the process, the procedure is, but teaching the understanding of it is very, very difficult. And this is what it would look like. So when you have a student who is at level A, right here, and this is level A, and then this is what the multiplication equal groups e-lesson or lesson plan looks like. And remember, this can be done over in your classroom. You could share it on a laptop, you could do it on a smart board, you could do it on a Promethean board. It's you know, this is your mini lesson that you're working on. So if you take a look, level A and level AA, these are the students you're working with, and right here it has concrete models level A, okay? And if you take a look down here, what it says is the strategy for level A is counts by ones to solve problems with equal groups. And it'll tell you, begin to understand how to manage groups, how many groups and how many are in each group, connect to addition and skip counting. So if you take a look with the lessons the mini lessons that you'll be doing with them, there's a bunch of these. We'll just go over a couple. It says how many groups are there. The prompts are at the bottom for you. So you would go ahead and say how many groups are there, how many in each group. Oh, there's 5 groups with 2 in each group. The next one says, how can we show this problem as an addition problem? 2 plus 2 plus 2 plus 2 plus 2, and the skip counting. Again, the next one, how many groups are there? How many in each group? We have 5 groups with 5 in each groups. How can we show this problem as an addition problem? 5 plus 5 plus 5 plus 5, or by skip counting, 5, 10, 15, 20. And then when you're done with that, again, this is when you're working with your students. You already saw what the independent part looks like. There's the multiplicative thinking book. And what you do is you go ahead and there's the answer sheet for level A and level AA. Remember, our goal is what? All about groups, repeated addition, and skip counting. So they're going to go through, and this would be their groups. How many groups are there? There's 3 groups here with 3 in each group, 3 plus 3 plus 3. And again, for skip counting, we have to skip count by 3s, 3, 6, 9. And this is what, using the lessons for level A would look like. So now we're going to go on to level B. And what level B is, it says student uses the additive composition strategy when calculating the total for equal group problems. To progress, they need to learn how to use the multiplier multiplicative as an operation, or the groups and the number in each group. And so we're going to take a look at what level B looks like.
$36.
Okay, how did you get that?
I did 6 plus 6 plus 6 plus 6 plus 6 plus 6.
So you just kept adding 6 and adding 6 and adding 6? Okay. How many cans of soda are there?
36.
And how'd you figure that out?
I will. 6, 12, 18, 24, 30, 36.
Nice job. Okay. How many squares are there total in that array?
44.
And how'd you get that answer?
I saw 4. For this row, then I saw counting 4, 8, 12, 16.
Okay. So you counted up by 4s then?
Yes.
All right. Okay, remember for level B, there's a lower side, which is sort of the repeated addition or additive composition. Then there's the higher side, which is the skip counting. Okay, in characteristics, understands that the count is a permanent indicator of the quantity. They can take advantage of the groups to count more efficiently. So once they figure out how many are in one group, they just keep going all the way through, and they trust the count. They know that there's going to be 4 and 4 and 4 and 4 and so on. Once the group is recognized, they do not need to go back and count the other groups, right? They understand the concept of the count. The quantity can be arranged in different ways, and it will not change. But the focus is on this, and this is sort of, remember, level B is, think we're level B about working on equal groups, but we're making this focus right here because this actually has to do with division. But think how far away we are from division, because if this isn't in place, it's going to affect their division. It says the focus is on the multiplicative, or how many in each group, but not the multiplier, the number of groups. So they view the multiplier as the number of when to stop counting. The multiplier is not coordinated with the multiplicative before the count. A little confusing, but here's what that means. When they're doing repeated addition or when they're doing skip counting, what he's doing is going, okay, 4, 8, 12, 16, 20, 24. He has not accounted for that he just counted 4 6 times. If there would have been 7 4s or 8 4s or 9 4s, he just would have kept counting. But in order to really understand division and be a multiplicative thinker, you have to be able to take the multiplier and the multiplicative, or the number of groups in the groups and the number in each group, and coordinate them before you actually start solving your problem. So instructionally, what we'll be focusing on is, well, them creating equations. So again, when they are, this is what a student who is functioning at level B, if they were given the story problem, 4 buckets with 5 in each bucket, how many apples would there be? They'd either do repeated addition or skip count by 5, 10, 15, 20. And then at the end, they'd know they'd have to write an equation, so they'd go ahead and write 4 times 5 equals 20, but they wouldn't have used that equation to actually get the answer. It would have been the last thing that they created, not the first thing. So when looking at level B, there's 2 goals, right? Just like level A, it's all about making sure that they understand there's groups and number in each group, repeated addition. Level B is all about this: create a multiplication equation. You need to write an equation. Level A, we didn't even worry about writing multiplication equations. Level B, it's all about that. And the second part of level B is teaching them about the commutative property. So if you take a look right here, what we have is we have an array, and a screened array too. And the reason why it's screened is because we want them to focus in on not just the number in each group, but the number of groups. So how many groups are there? How many in each group? Use the multiplier and multiplicative to create a multiplication equation. What is the total, right? Remember, number in each group, or how many groups too. You don't have to use the term multiplier and multiplicative. And again, right here, we have a 3 and then a bunch of 3s turned over. Okay, we have 3 in each group, but how many groups are there? So you want them to focus on not just how many in each group, but how many groups are there. And again, working on the commutative property. So again, right here, screened array. And remember, with arrays, you can go ahead and rotate it. So 5 times 6 and 6 times 5. And again, every question has to do with them producing a multiplication equation, right? They work with the part whole model at level A. Now we've actually covered up the answer. They have to focus in on the groups, the number in each group, and then give us the total and write an equation. And again, when working on the commutative property, go ahead and with cards, you can go ahead and give them 3 4s, which would be 3 groups of 4, or 4 3s. And what's great about the commutative property too is when you use an array, all you have to do is rotate it. This is really easy for them to understand. It's hard for kids to understand that this right here is also the commutative property, and that 3 and 4 and 4 and 3 are going to equal the same thing. So when you start teaching about the commutative property, use the arrays first and rotate them, and then go on and start working with equal groups. But remember, the entire focus is creating equations. So this is what, again, using the materials or the e-lesson, and what it would look like. So you have level B, which is additive composition, or they're using skip counting. So if you take a look here, there's 2 different parts of this that have to do with level B. And one is the partially screened models, and the other is what we'd be working on is the commutative property, okay? So we'd go ahead and take a look right down here, and it tells us about level B, and to create equations using both the multiplier groups and the multiplicative number in each group. And that's exactly what we're going to do. So take a look. Remember, the question prompts are down here, and it's really neat how this works. How many groups are there? Well, it's screened in a way that we can't see all the groups. So we don't know how many groups there are altogether because we can't see under the screen. So all we can see is one group, right? How many in each group? Well, we know there's 5. So what's missing? Well, we don't know how many groups there are, but we do know that there's 5 in each group. Then the next slide, what does it do? It shifts over. So, okay, now I have to start paying attention not just to how many are in the group, but the groups themselves, and go ahead and create an equation, okay? Now for the next one, again, they can't see how many groups there are, or they can't see how many groups, they just can see how many in each group. Then we'll go ahead and say, okay, now we're going to shift it over, and what this does, it forces them with their eyes to account for both the groups and the number in each group. And then the next thing would be, when you're working on the commutative property, this is a different set of lessons, you click on it, and it just says write an equation for each picture. What do you notice? And that's just an array that's been rotated 2 times 7 and 7 times 2. And that is working now working in the multiplicative thinking book. Again, level B has to do with groups, number in each group, and writing a multiplication equation. So when they would go through and work in this book again, it's all these screened arrays. And remember, when they're working the multiplicative thinking book, this is what they're doing with you. There's only 6 problems. You're watching them work on this and so you can sort of problem solve and troubleshoot any problems that they may have. And again, for the commutative property, it says no answer sheet needed. You don't need an answer sheet for that. You would just print this up. And some of the things, the multiplicative thinking book, you need the answer sheet. Other things you don't. It tells you if you do or not. Okay, what's interesting about students who are in level C, and level C is a good level to be at because it shows that they're able to do thinking at level D, they're just not consistent with it. So they sort of float in between level D and level B with what they do. And it says student alternates between additive composition and flexible reasoning. To progress, the student may need to practice facts. They may also need instruction that focuses on identifying the structure that exists within each problem. So we'll talk in another slide or two about the instructional decisions you have to make with level C, because it's not always as obvious as level B, level A or B or C or so on, okay? Okay. All of the cards are 4s. What is the total?
16.
How'd you get that?
Because you said there was 4 in each, so 4, 8, 12, 16.
Okay, so he skip counted. If there were 4 tables in a room that looked exactly like that, how many people would there be? So there's 4 tables that look just like that.
20.
And how'd you get that?
Because there's 5 people at the table, and if you times it by 4, it's 20.
Okay. Use multiplication. The rectangle is covering up some of the dots in the array. How many dots are there total?
15.
And how'd you get that?
Because you said that there was, if you count, there's 3 in each row, and there's 1, 2, 3, 4, 5, and if you times it by 3, it's 15.
Okay. So characteristics, it says situationally understands a multiplier and multiplicative and are coordinated prior to the count in order to produce a multiplication operation. Situationally understands multiplicative situations involve 3 aspects: groups of equal size, multiplicative, number of groups, multiplier, and the total of the product. May have a basic level of mastery of facts. Most children at this level need mastery of facts to move to level D. So the only difference, I don't want to say the only difference, but level C students often have a pretty high level of understanding. They just don't have complete command of their facts. So again, a level C student, when they're doing the same story problem, there are 4 buckets with 5 in each bucket. They may either go, 5, 10, 15, 20, or they may just say, oh, that's 4 times 5 and that's 20. And what usually determines their strategy is how comfortable they are with a particular math fact. If they know it, they'll use it, and if they don't know it, then they'll revert back. So when doing instruction at level C now, if we take a look, level C is a really interesting level because there's going to be two reasons why a child is a level C, right? And if you take a look, there's nothing in this lesson plan that is specifically for level C. There's things for level, there's things for level A and level B and C, and everything is shared, but you're going to see there's nothing specific that says just level C. So what you have to decide is when you're working with a student, okay, why are they a level C? All right, and there's going to be two reasons, right? One is, do they know their math facts, but they just don't consistently use them? So if a child knows their math facts and they're not consistently using them, they need more work on the structure, right? And identifying it and connecting it to it. Is the weakness in facts holding them back? When they know the fact, do they use it? And also, when you give the assessment, you're going to have a score for their multiplication division facts, which will help you also determine this. But if a child knows their facts and they're not using it, you would do more structural teaching and partially screened models. That level B, level C that we just saw when we were working with level B would be the type of instruction that they need. If they are, if their weakness is facts and the facts is holding them back, but they have the thinking, you would do two things. One, you could go ahead and start to instruct them at that level CD with the partially screened models, which has to do with one more and one less. Because remember, a lot of students who are level C are very high thinkers. They just don't have command of their facts. And also at level C, what you could do is this is when you could focus in on math facts. So if you think about, earlier today we were talking about when is it kind of appropriate to just have students focus on math facts? Level C is a perfect level where you could actually say, all right, we're going to have you work on your math facts. Now, a student who's on level A, math facts is just too far of a bridge for them. Not that they can't work on it, but it's not going to solve, what their problems are, what they're missing. Again, level B, the math facts isn't going to solve because they have structural issues, structural understanding issues, not just math fact issues. So if a child's a level C and the weakness is facts, you can still give them higher level instruction, level D instruction for the structure, and also work on the math facts. Okay, level D now, and level D is exactly where I want our students to be. It's where all your standards are written. So if you look at 3rd and 4th grade standards and match it to the framework, all those standards are requiring them to be thinking at level D. And level D says student consistently and efficiently uses the multiplier and multiplicative simultaneously as an operation. To progress, the student will need to understand the inverse relationship between multiplication and division.
All right. Now, how many cans of soda are there total?
36.
How did you figure that answer out?
I counted one group of the cans and they had 6, and then I just did 6 times 6.
Okay. How many dots are there in this array?
20.
And how did you figure that out?
They're 5 times 4.
Okay. How many beads are there?
13.
How'd you figure that one out?
I did 3 times 4 plus 1.
If there were 4 tables in a room that looked like this, how many people would there be?
Oh, I was thinking of chairs. Okay. 20.
How'd you figure that out?
5 times 4.
Okay.
So characteristics, it says understands the multiplier and multiplicative are coordinated prior to the count, right? They'll create an equation. Understands multiplicative situations of all 3 aspects, okay? They're able to use multiplier, multiplicative, and product, and can use the relationship of the product and groups to solve for one of the things is missing. So we'll take a look at what level D instruction looks like. Can create a new equation with a sudden change to the structure, and mastery or close to mastery of facts. So again, for level D, this is how a student would solve it. They'd look at this problem and just use a fact. And so when looking at the leveled activities guide too, the first part of this is making sure that they understand. So they're going to be given, instructional things, and there's 2 parts to it. Write a multiplication for this picture. They're not going to have any problems with this. Write a missing factor for this picture. So they would go ahead and you'd say, okay, you need to go ahead and say if it's 4 times 5, leave one of those out. So 4 times something equals 20, or 5 times something equals 20. We're going to get into more detail of missing factors when we work on the division connection, but for this part, we're going to say just pick one of those numbers just so they know you can have a missing factor equation. If one more group is added, what would the equation be? And again, kids who are level D, they usually get through this instruction of just extending their understanding. It's really easy. And think an equation for a picture, they'll have no problems. Missing factor, not a big deal. And then if one more group is added, then again, that's really easy for them. But level D, once they can do those things, this is huge. And it's called the division connection or the missing factor. And what this has to do with, they're not going to start doing division problems. They're going to start actually giving multiplicative situations with missing information, and they're going to have to write not a division equation, but a multiplication equation matching the scenario with missing factors. And this will be how we work on the bridge to division. So here's what it would look like. So level D, if you take a look, where all level D is, and remember, some level C kids will also receive this instruction. If the only issue is a child just doesn't have their facts learned, they can go ahead and still continue to have this too. So if you take a look, partially screened models, this would be one more or one less, okay? And this is where level D, and that just tells you what you want to focus in on. And then algebraic models would be D+, once they can do the partially screen one more or one less, and you'll see what that looks like. Then you go to algebraic models, which is, and if you take a look right here where it says the division connection, this is a really important developmental thing that you have to go through. So if you take a look here again, this would be in the E lesson, right? And it says, write a multiplication, what multiplication equation can represent this picture? And they're going to go ahead and say, oh, 3 times 6. If there was one more group, what would the equation be? Okay, and again, one more group's put in there. Then they have to go ahead and do 4 times 6 is 24. Again, this is not very difficult for them, but it's something you need to make sure is in place. Once you go through and they can do, add one more group or one less group, then what you can do is you can go ahead and go to the algebraic models, the division connection. This is, remember, it says D+. Now, D+ is not a tested level. It just means you've gone as far as you can with level D, and now they're ready for this division connection. So take a look at what this says. It says 18 jars, 3 in each group. How many groups? All right. Also, this is a measurement division type problem, but here's what we're going to say. Look at the prompts. How many groups? How many each group? How many total? And so again, we don't know how many groups there are, but we know there's 3 in each group, and we know there's 18 jars. So write an equation with a missing factor. Remember, we don't know how many groups, so it's something groups of 3. And then the prompt says, what number times 3 equals 18? It'd be 6 times 3 equals 18, okay? And again, 18 jars put into 6 groups. Now this is a partitive division problem. But again, we're not solving it in the division way. What we're doing is we're solving it with a multiplication equation with a missing factor. So we know there's 6 groups. We don't know how many each group. So again, the equation is going to look different. Now it's 6 times because we know how many groups, but not how many in each group. And equals 18. Again, 6 times what equals 18 equals 3. So we're making a division connection. We didn't say the word division. We're still solving it through missing factors. And again, the same one, a different model, 24 partition 8 to a group. How many? Okay, and the last part that I want to go over is just this last part right here. We've gone over everything, but we have not gone over the multiplication 2 digits by 1 digit and multiplication 2 digits by 2 digits. So just to be clear, before you work on this, you wouldn't start working on this if your students get to level D right here. They need to be at level D at everything, especially for multiples of 10. So don't think, okay, I've gone through everything. They've done the algebraic models, and now we're going to do this. This is sort of, it says D+, where it means that they have to have everything here. So this is what the framework should look like when you get to this. And here's just what some of it looks like too. So remember, level D across the board almost in everything. And then, again, if you have a 3rd grader and they're ready for this, go ahead and teach it to them. There's nothing wrong with going above and beyond for students who are ready for it too. So, and for 2-digit, 1-digit, what it does, it teaches them different strategies, right? So the office buildings, windows were arranged in a 7 by 14 array. How many windows are there? And then go ahead taking them through and showing them how that works too. So not just teaching them the process, the procedure, but how to apply it. And then there's other methods too, again, place value sections, expand and notation. And remember, for all of this is, the idea is when you start working on this is, you know, your 4th grade stuff, your 5th grade stuff, they need to be at a level D at everything before you can start working on this right here. So remember, this is sort of your goal to get here, but everything has to be up to par for that. So now we're going to go through the division. Remember, we learned earlier about measurement division and partitive division. And what level A represents, just like level A represents some type of counting by ones, level A represents a student tries to solve division problems by using the one-to-one counting strategy, either perceptually or figuratively. Student may need to draw out the problem. To progress, they may need to connect division to multiplication. So the characteristics are very similar because multiplication, division are an inverse. So you're going to see a lot of parallels between the multiplication and division. So let's just take a look at what a level A student looks like.
The tree has 20 apples. 5 apples will go in each bucket. How many buckets are needed? So there's 20 apples, and they're going to put 5 apples a bucket. How many buckets will they need?
And this is a measurement division problem, so he knows how many are going in each bucket. Take a look. He fills up the first bucket. Now he's filling up a second imaginary bucket. Now he's filling up an imaginary third bucket. And now he's going to fill up an imaginary fourth bucket and tell us there's 3 more buckets.
3 buckets.
3 buckets?
Yeah.
Okay. And I saw how you did that. You just kind of pretended to put them each in the bucket?
Mm-hmm.
All right.
That's apples again.
There are 21 total apples. I want you to even divide them into 3 boxes. How many apples are in each box?
So remember, this is partitive division now. He doesn't know how many are going in each box. Well, this is going to be more difficult for him. Remember, measurement, you knew how many were going in each group. Partitive, you don't know how many are going in each group.
This one's tricky. This one's hard. I don't know it.
Okay, we're going to go to the next one, okay?
Okay.
The 18 donuts are equally put into 6 boxes. How many donuts will go in each box?
I'm trying not to skip up by 12, but I can't, so.
Partitive division again. He doesn't know how many would go in each box. Because he doesn't understand the relationship between that 6 and that 18.
8, 9, 10. Wait, can you add that?
So 18 in the 6 boxes.
5 each. 1, 2, 3.
We're going to go on to the next one, okay?
Okay.
It's a tough problem, isn't it?
Yeah.
All right, so grouping does not make sense, does not realize that skip counting, or you could say repeated subtraction for some of them, will give them the same total as counting by ones. And remember, he got the measurement division one correct because he was able to sort of deplete that 20 until he had none left. All right, does not see the count as permanent indicator of the quantity or collection. It does not trust the count. It may be able to make groups to represent a given multiplicative situation. However, they count by ones from the beginning. So if you take a look at this, for level A, How would a student solve this division problem? There were 20 total apples. Evenly put them into 5 apples per group. How many altogether? So again, a teacher could be fooled because they could go ahead and see this and say, oh, okay, good. He drew out the groups. He understands the division. They even wrote a division fact. But in the end, what they're really doing, they're not using the fact. They're just producing the equation because they were told to. They're going back and they're counting by ones all the way. 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can get the impression that, oh, they used 20 divided by 4, then they drew out what it meant. But what they really did is they drew it out one by one and then just came up with an equation because they knew, oh, we're working on division, I have to write an equation. Okay, for a student at level B, remember it says student solves division problems by use of additive composition or subtraction. To progress, student needs to understand the direct connection between multiplication and division and understand its inverse relationship. Now remember, these students are going to be able to solve these division problems correctly using either repeated addition or skip counting or repeated subtraction. But what's important to understand now is they still have to understand that relationship between multiplication and division, because the next concept they're going to be using is going to be multiplying and dividing fractions. And if they're trying to use skip counting and additive composition, and they don't understand that relationship or the inverse relationship between multiplication and division, they're going to have a really, really hard time because the strategies they're using will be much more difficult to do when they're working with rational numbers.
Kangaroo jumps 3 feet per jump. How many jumps will it take kangaroo to jump 15 feet?
5 jumps.
And how'd you figure that out?
Counting by 3s.
Can you show me how you did it?
3, 6, 9, 12, 15.
Alright. Alright, ready? The man has 24 cookies. He put 6 cookies a bag. How many bags does he need?
He has 6 bags.
And how'd you get 6 bags?
Counting by 6s.
Okay, and explain to me how you got 6 bags.
How I got 6 bags was because you said there was 24. No, there's not 6 bags, there's 4 bags.
Okay.
Because it's 6, 12, 18, 24.
Okay.
And that's 4 times, so there's 4 bags.
Gotcha. Alright, good job. Okay. The tree has 20 apples. 5 apples will go in each bucket. How many buckets are needed?
4.
And how'd you get that?
Counting by 5s.
Okay.
Okay, and that's what level B looks like. And again, a student who's functioning at level B, when they're given 20 total apples, you can put them into 5 apples per group. How many will there be? They'll either go 5 plus 5 plus 5 plus 5, or 5, 10, 15, 20. And then they'll write the equation last. So again, the equation is not the beginning step, coordinating the groups and numbering each group. And, and we'll talk about, at the end of division, we'll go back and look at what you do for level A, B, C, and D instructionally, because we did that for multiplication. We will do that for division, but we'll go through all the levels first. So next is level C, right? And level C are kids who kind of float between level D and level B. And so it says students solve division problems by alternating between sort of additive composition or skip counting and flexible reasoning. To progress, student needs to focus on understanding the relationship between multiplier, multiplicative, and product. And this is what a student looks like who's level C, who floats between level B and level D.
Alright. The man has 24 cookies. He put 6 cookies in a bag. How many bags would he need? So there's 24 cookies and he's going to put 6 in a bag.
Okay. I need 4 bags.
You need 4 bags, and how did you get that?
Because I did 6, 6, 6, and 6.
Okay. So.
And I got 4.
So you say you skip counted then? Okay. The tree has 20 apples. 5 apples will go in each bucket. How many buckets are needed?
4.
And how did you get that?
I got it by 20 divided by 5. I automatically knows. Well, first of all, I know 5 times 4 equals 20, and then 20 divided by 4 equals 5.
Excellent.
So again, you saw him, he went in between, using a fact. He even not only gave a division fact, but even gave us the missing factor multiplication equation and the division fact as well. So that's sort of level C, floating between the two. Remember, level C is a high level of thinking, and normally they just need to learn, strengthen their facts, and they'll be all right. And here's what level D would look like now. Oh, sorry, for level C, again, a level C student would either go 5, 10, 15, 20, or they would just go ahead and use the division fact, depending on how comfortable they were with the equation, and that's how they'd solve it. Okay, and this is level D. Remember, level D says student solves division problems by consistently applying flexible multiplicative reasoning. Student has a proficient understanding the inverse relationship between multiplication and division. And remember, they'll be able to produce an equation prior to the count.
The man has 24 cookies. He put 6 cookies in a bag. How many bags does he need?
4.
How'd you figure that one out?
Because there's 24 cookies and 6. He put 6 in each bag. There's 24 divided by 6, which is 4.
Okay. There are 21 total apples. I want you to evenly divide them into 3 boxes. How many apples are in each box?
7.
How'd you figure that one out?
Because 21 divided by 3 is 7.
Perfect. The 18 donuts are equally put into 6 boxes. How many donuts will go in each box?
3.
How'd you figure that one out?
There's 6 boxes, which makes it 18 divided by 6 equals 3.
Okay.
Okay, and this is why this is really important too. Okay, again, for level D, what students will do who are functioning at level D, they'll just look at it and they'll either come up with a missing factor multiplication equation or a division equation to solve it. Okay, and this is instructionally what it would look like now. Now, with students level A, or B, the interesting thing is, and you'll see it in a second when we get the lesson plan, these are all things that you'd be doing with them at level D in multiplication equal groups. So if they're level A or B, you actually are not working on division with them. You're going back and working on multiplication with them. So if you take a look at with the lesson plan, it'll tell you go back and work at multiplication level sort of D+. If you remember what that was, D+ had to do with writing missing factor equations and matching pictures. So this is all of what you would be doing here. And then when they're in level C and D, that's when you'd start to do the actual division equation. And so I'll show you in a second what that'll look like when we get to the lesson plan. So remember too, we're spending all this time on developing multiplicative reasoning and the relationship between multiplication and division, not just for what we're working on now, but for what's coming too. And though this is not a fraction course, let's think about this, right? So 4 divided by 1/2. And again, a lot of kids have no idea really what's happening. Even a lot of teachers are not necessarily sure what's happening. We tell kids, okay, flip the fraction and multiply and it equals 8. And it's like, how can you divide and end up with more than what you started with? So when you're explaining this to your students, you don't want multiplication, division, or fraction just to become so procedural, because they'll never be able to apply it to a story problem or anything else. So let's take a look, okay? So what you're saying is, if it's 4 divided by 1/2, what you're saying is, how many times will 1/2 fit into 4, right? This is like a perfect measurement division type problem. So how many 1/2s will go into 4? Well, 1, 2, 3, 4, 5, 6, 7, 8. So you have 8. So understanding that 8 means 8 1/2s go into 4, and them understand that this was just a form of a measurement division problem. So again, making sure they have a strong foundation and understanding what's happening. So again, 4 divided by 2 is something they'll easily understand. 4 divided by 1/2, they should understand that the exact same way. So we're making sure they have a strong foundation for that. So this is what the division lesson plan looks like. And what's important to understand is, if you take a look for the division levels, there is nothing on here for level A and level B. And the reason why is, if you go through and look down here at where it says level A and B, it tells you you have to go back and work on multiplication of equal groups with a missing factor, right, as a multiplication equation, okay? So if they're level A or B, you don't try to do division with them, you actually go back and work on multiplication of equal groups, if that makes sense. Because remember, when you get to level D in multiplication equal groups, that's where the division connection starts, and that's what they need to have. So level A and B, you go back to it. And remember, you've done a lot of work with multiplication of equal groups to build towards division, so division should be easier now. So that's why we're doing that. So again, for level B and C, they have algebraic models, and then there's story problems, division story problems, and then there's 2-digit by 1-digit with remainders. That would be like a, when they're able to function at level D and you want to expand them, it goes to remainders. Then it goes to division 3-digit by 1-digit. Now we're not going to have time to go through all aspects of it. I think you have a good feel for what the types of things that are in the multiplicative thinking program. So we'll just take a quick look at the algebraic models and what the transition to division looks like. And this is it. So this will look very similar to what they did. And remember, we spent a ton of time with equal groups, so division would be easy. Like we invested all this time, we spent most of our time is spent on equal groups. Now this is where we're hoping that all that time will sort of pay dividends now, right? So it's 18 jars, and big thing is now the word divided actually exists. If you look at previously, it never says divide. It'll just say 18 into 3 groups, 18 divided into 3 to a group. How many groups, right? So it says, we don't know how many groups. There's 3 in each group, 18 total jars. This all looks very, very familiar, but here's where the change is. So it says, write an equation with a missing factor product first. So now they're writing an equation, but you're going to make them write it with 18 equals. We don't know how many groups times 3. Then it says, write a division equation, 18 divided into 3 to a group, right? And so we would go ahead and say 18 divided by 3, and there's our connection. They just went through those progressions of a multiplication equation, measurement division, product first, missing factor equation. Now they have a division equation. And then they go through and they solve the missing factor multiplication equation and the division equation. Because think about it, 18 divided by 3, what are you saying? You're saying 3 times what equals 18? And that thinking was established there, that they're already familiar with too. They just had to put the product first. So that's how you do the division connect. Okay, extending multiplication rate and multiplicative comparison. These are just a different type of multiplication problem. All the problems they've dealt with up till now all involve like the equal groups type format. And rate is a type of ratio multiplication problem that involves the measurement of time, currency, speed, etc. So it's not always structured as equal groups. And multiplicative comparison is comparing 2 sets that need multiplying. Equal groups is not an accurate description of the structure of multiplicative comparison either. So it's just seeing can they apply sort of multiplication principles to a different type of problem that just doesn't involve equal groups. And here's what level A would look like as a rate problem.
It takes 2 minutes to wash each window pane section. So each of these little sections right there, it takes 2 minutes to wash one of those. How long would it take for someone to wash all of the window panes?
If you see, she's clearly counting by ones.
18?
18 what?
18 minutes.
Good.
Okay, and here's what level B looks like. Again, this would be a rate one. Again, rate for a rate multiplication problem.
Man can walk 5 miles in 1 hour. How many miles will he walk if he walks for 6 hours?
Wait. 30.
And how'd you get that?
I counted by 5, 6 times.
Okay. It takes 2 minutes to wash each window pane section. How long would it take for someone to wash all the window panes? So it takes 2 minutes to wash one of these sections. How long would it take him to wash all of the entire window? Okay, and how did you get that?
I counted by. I know that there are nine squares, and I did 9 times 2.
The man can walk 5 miles
level
in
D.
1 hour.
Remember level
How many
C.
miles will he walk if he walks
Level
for
C
6
would be going in
hours?
between level B and
30.
level D.
How'd you figure that out?
5 times 6.
Okay. You're a good listener, Caitlin. It takes 2 minutes to watch. Excuse me. It takes 2 minutes to wash each window pane section. How long would it take for someone to wash all of the window panes?
18.
How'd you figure that out, Caitlin?
9 times 2.
Is the second lizard twice as long as the first? Explain why.
Multiplicative comparison.
Yes, because if you add 4 more to the first lizard, it would equal the same.
Okay. Does the second dog weigh 3 times as much as the first? Explain why.
No, because 8 times 3 is 22.
Okay.
Also, for multiplicative comparison, if you take a look at where it says extending multiplication, it'll say level A counts by ones or level B uses additive composition. Though those strategies apply for rate, multiplicative comparison, students either understand it or they don't. They're either going to be a level like D or a level A. It's almost impossible to figure out a multiplicative comparison problem by counting by ones. So even though it has level A, B, C, and D, and rate and multiplicative comparison are rolled in together, you'll see how it's scored when you give the assessment. But there really is no, for comparison, they either know how to do it or they don't. Okay, and these are just some activities, and this is on the leveled activities guide that you can do to teach your kids about rate or multiplicative comparison. Okay, now the multiplicative connections, the inverse relationship, this is essentially seeing, okay, everything they've learned about multiplication, division, can they sort of formally show the connections between the two? So again, a level A means that they wouldn't be able to do it, and then they're asked 3 different questions. So level B would mean they have one of the three connections. Level C would mean they have 2 out of 3 connections, and level D would mean they have 3 out of 3 connections. You realize there's no level A here, and because level A always represents accounting by ones, so it's just left out. There either be a level B, C, or D, depending on how many they get right. Here's what a level AA student would look like.
Three times 8 equal 24. Can you use this problem to help you find 4 times 8?
Yeah.
Think about the multiplication earlier, adding
Okay, how can you use 3 times 8 to help you solve 4
Well,
times?
because it goes 3, 4, and then there's 2 8s, and if I say 24 was in there, I can just, and then there's 2 problems on the paper. So 4 is just one level up from 3, so if that's 24, I think that's 25 because it's just one above it.
Okay, so you're saying if 3 times 8 equals 24, 4 times 8 it would equal 25 because it's one more above it?
Yeah, because it goes 3, 4.
Okay.
And then all I did was add 8 to that.
To the top one?
Like what I did was, all I did was add 8 to this one.
Okay, and you got 24 plus 8 and that equaled 32, but you already knew it too. Good, well it's still good that you understood that, so,
Yeah.
okay. The top problem says that 6 times 4 equals 24. Can you use 6 times 4 to help you solve 24 divided by 6?
Yeah,
And what's the answer?
4.
And how'd you know that?
Because all you did was switch these 3 numbers around. It would be 24 divided by 6, and then that would be the middle number, 4.
Alright.
And So what you're doing, and we go through the assessment, you'll see this entire section in detail, but you're just looking for, can they say, 6 times 4 equals 24, and then 24 divided by 6 equals 4? Can they make that connection between those two problems? And again, if you look at what you would do for kids who are struggling with multiplicative comparison, these are all the exact same activities that you did with equal groups, multiplication, and also with division too. So there's nothing specifically different that you would do. We go back to working on equal groups or division as well. Okay, and this last part is multiplying by multiples of 10, okay? And what's important about this part is if you remember the very last part of the framework, which has to do with multiplying multi-digit, and that's where the 4th grade, 5th grade stuff would come in, they have to have this in place to be able to understand and use those strategies. So this is why it goes through their ability to multiply by multiplying by 10. And remember, if they see 8 times 10, they should know it's 80. If they count by 10s 8 times, that's going to take them, it's too inefficient of a strategy that they're going to be using when they use the multi-digit multiplication strategies. So we'll take a look at what it looks like. This is what an AA student would look like.
Okay, 10, 20, 30, 80.
And as you saw, she counted by 10. So even though she got the right answer, too slow of a strategy for what she's going to be asked to do. And now this student, he's going to go through all aspects of multiplying by multiples of 10.
Now I'm going to ask you some multiplication problems. Answer the best you can.
Single digit times 10.
80. 60.
2-digit number times 10.
140. 40. 380. 450.
Multiple of 10 times the single digit number.
120. 120. 360.
Multiple of 10 times multiple of 10.
1,500. 4,500.
Okay, again, all of those the types of problems you just did will be essential that they understand that when they go through and when they do, multi-digit multiplication, whether it's place value sections or expanded notation, they'll need to be really fluent with all those. So that's why it measures that. Okay, take a look at this story problem now. This will be our last thing that we do with this section. And this is just to show that, remember, multiplication, division, yes, we're worried about teaching now, but it's also about teaching what's coming next too. So it says a cake recipe requires 2 cups of milk. How many cakes can be made from 10 cups of milk? And again, this is not a really difficult problem, okay? But now take a look at this next problem. A cake recipe requires 1/4 of a cup of milk. How many cakes can be made from 3 cups of milk? Again, for students who don't understand the relationship of multiplication division, this is a really a common way a lot of kids would go through and solve it. They almost remember counting by ones. They're going to go through and say, okay, how many 1/4 make 1 cup? Okay, 4. And then how many make 2 cups? Another 4. 3 cups would be another one. And then go back and say, okay, I have my 3 cups, and then 1, 2, 3, 4, and go through and figure it out that way. So again, an additive thinker can still solve some more difficult problems, but think about how time-consuming this is. Now look, another student can have the same problem. A cake recipe requires 1/4 of a cup of milk. How many cakes can be made from 3 cups of milk? So what you're hoping is, okay, students can say, oh, okay, how many 1/4 will fit into 3? Remember, this is a measurement division type problem. And then hopefully they'll say, okay, I can tie this to the procedure now of 3 divided by 1/4. I'm going to flip it, and then I'll get 12. So this is just showing, when students are additive thinkers, they can continue to be additive thinkers even when they're are doing more advanced math, but they're still functioning at a very low level. And we're going to give the multiplicative thinking assessment. If you're all at home watching this, if you want to have a copy of the assessment, you would go to numeracyconsultants.net and click on webinars. And then if you just go down to the very bottom where it says multiplicative thinking webinar, you can go ahead and click this and download it, and then you can print your copy and you'll have a copy. If you don't have a printer or not access to it, it's okay, because the assessment will actually be on the screen. So that's just how you get that. Go ahead and get this set up real quick. Okay, and the way the multiplicative thinking assessment is set up is when you go to the very first sheet, it's a cover sheet. And what this is, it's a summary. So as you go through and you give this assessment, you'll have a skip counting score, and then a multiplication fact score, and then we'll get into the problem structures of equal groups and division and rate and comparison and so on. So we're going to go through step by step of what the assessment looks like, okay? We're not going to give the first part because we're trying to keep this webinar as close to 2.5 hours as possible. And this is actually a really time consuming part because they're going through and they're actually skip counting for you. But the girl who we're about to score, she was able to do her 2s, 5s, and 10s. So if you take a look, if they have 2s, 5s, and 10s, they're considered to be a level B. If they only have 2 or less of those, they'd be a level A. Level C would be if they have any combination of the next 3, then level D would be that they have all those. So she had her 3s, she had her 4s, and she did not have her 9s, 7s, 8s, or 6s. The only thing you need to be on the alert for is a student may do something like this. They may go 6, 12, 18, and then when they get to 18, they'll go 19, 20, 21, 22, 23, 24, 30, under their breath, or they'll try to whisper it. That's not skip counting, that's repeated addition. So that would not be fluent. So if they evolve from skip counting to adding, that's just not fluent, okay? All right, the second part is there's a multiplication division fluency part. And all that part is, it gives them 10 problems, 10 multiplication problems, 10 division problems. At the very last page of this assessment, it looks like this. It's just this piece of paper. You give them 30 seconds to do the multiplication problems. It's 3 seconds per one. And then you give them 30 seconds to do the division problems. And then you will have a score for those answers, okay? And then so when you're done, you'll go back and you'll take a look, and then you just record their scores where they're at for there. So now we're going to go ahead and go into the equal groups. And so the equal groups is set up. There are 8 problems. There are 4 concrete problems, which means they can see the multiplier, the multiplicative, and the total. And then there's 4 where there's some missing information where they're not given a piece of information. So we're going to go ahead and take a look now at multiplicative groups. How many cans of soda are there total?
There's 6 in each of them total, in all.
How many cans of soda are there total?
6, 12, 18, 24, 36.
36, okay. And you figured that out, you were skip counting, I saw, okay.
Okay, and she skip counted, and she got the answer right, so she gets credit for the strategy and the correct answer.
How many squares are there total?
So I want to count the rows. So there's 3, 6, 12, 8, 24.
24, and how'd you get that?
I just said, is there? Yeah, there's 6, 12, 18, 24.
Again, she skip counted and she got the correct answer, so she gets credit for the strategy because she got the correct answer.
So 20.
Okay, and how'd you get that?
Skip count by 4.
Okay.
Again, she skip counted and she got the correct answer, and she gets credit for the strategy.
All right, how many beads are there altogether?
Altogether, 36, 9, 12. 13.
Again, she skip counted and added 1, and that is correct. Now this next set, you're going to take a look. The first 4, they could see everything. All the information is there, groups, number of each group, and the total. Now they're not going to be able to see the total. And they're going to be given a number and group and the number of groups and how many in each group, but now they're not going to be given the total. So it's more abstract.
Cards are 4s. What is the total?
4, 8, 16.
And again, she skip counted.
4 tables in a room that look like this. How many people would there be?
So there's 4 tables. There's 4 tables, I think.
Well, there's 4 tables were in a room that look just like that. How many people would there be?
So 1, 4, 4, and then 5? Like 5 at each table?
Okay, so how many? There's 5 people at that table, right? So if there were 4 tables in a room that looked just like that, how many people would there be?
4, 8, 16.
There'd be 16 people.
I don't know those.
Okay.
Hard.
Okay, she tried to skip count, but she did not get it right, so she won't get credit for it. So that's actually an incorrect answer, but that's how you document it.
The rectangles covering up some of the dots in the array. How many dots are there total?
36, 9, 15.
Again, she skip counted, and she got the correct answer, so she gets credit for the strategy.
There are 4 shirts in each drawer in this dresser. How many shirts are there total?
4, 8, 24.
Okay.
And again, she got the correct answer. She skipped count, got 24. So if you take a look right here, this is just, it's sort of like when you're done with the section, go ahead and score it. Then when you're done, you don't have to keep going back. So if we take a look, we know that she got 1 incorrect, and then she got 7 correct, and she used the skip counting strategy. So this is how it's scored. Then we'll come back when we're doing the levels, and we'll show you what she's at. But she is a level B right here, and she got 1 incorrect. All right, now we're going to go on to division. Remember, there's going to be measurement division questions. There's going to be partitive division questions. So think about this too. She showed us she was really, she's pretty fluent with her skip counting. That's her strategy of choice. Let's see if she has enough skill in place to solve these division problems. And each problem gets a little bit more difficult, and it works its way. It starts with measurement, where it's really concrete, and then becomes more abstract and works its way to partitive.
Kangaroo jumps 3 feet per jump. How many jumps will it take kangaroo to jump 15 feet?
36, 9, so 5.
Okay. And you skip counted?
Yeah.
And she skip counted, and she got it correct. Let's take a look at the next one now.
The man has 24 cookies. He put 6 cookies in a bag. How many bags does he need?
This is measurement division, but more concrete or more abstract.
4.
In a flashback, it showed you that she needs 24
There's 24 cookies. And he's going to put 6 in each bag. 6 in a bag. How many bags would he need?
So 25. So there's.
You can go up there if you have to.
Okay, there's 6. Or I don't know if to count 5. Or do you have to skip count?
Well, your strategy is up to you. But so there's 24 cookies, and he's going to put 6 cookies in a bag. But how many bags would he need?
So 6 cookies in each bag. 36, 9. I'm counting like this. 36, 9, 12. Or now that wouldn't make sense.
Well, so again, I'll ask it one more time. So there's 24 cookies, and he's going to put 6 cookies in a bag. So how many bags is he going to need to put all those cookies away?
So 6
6 bags? Okay.
Okay, she tried the skip count, but she didn't get the correct answer, so she does not get credit, and that would be an incorrect.
The tree has 20 apples. 5 apples will go in each bucket. How many buckets are needed?
So how much apples?
So there's 20 apples on that tree. If we were to count them, there'd be 20. And if five apples go in a bucket, how many buckets would be needed? 6 buckets. And how'd you get that?
I counted by 5s.
You counted by 5s and you ended up with 6 buckets?
Yeah.
Okay.
Again, she attempted the skip count, but she didn't use the strategy correctly, so it's incorrect. And next, we're now going to partitive division.
There are 21 total apples. I want you to evenly divide them into 3 boxes. How many apples are in each box?
Remember, she could do 21 divided by 3.
7.
Okay.
How many apples?
So there's 21 apples, and then we want to put it equally into those 3 boxes.
Okay, so I don't get this. So are you so there's 24 apples.
Actually, how many apples does it say there are?
I mean 21 apples.
There's 21 apples, and so they have to be split evenly in those 3 boxes. So there's none in those boxes yet. We have to put them in the boxes.
So slide them in there?
Well, we're not going to be able to slide them in there because it's not. So that 21 means those apples. So we know there's going to be 3 groups, right? Or 3 boxes. So how many would go in each box if we did it evenly?
9.
9. How'd you get 9?
I just said 3, 6, 9.
Okay.
Because I just skip counting is easier now.
Skip counting works easy for you? Good.
Again, she tried the skip count, was not able to use the strategy properly, and she got the incorrect answer.
Those look so good.
The 18 donuts are equally put into 6 boxes. How many donuts will go in each box?
6, 12, 30. I'm gonna say 2.
And how'd you get 2?
I guess 2, 4, 6, 8, 10, 12.
Okay. So that's how you solved it? You skip counted by 2s? Alright.
Yeah, because in those boxes looks pretty small.
Okay.
And remember too, she's been tried to do with partitive was use the trial and error strategy. So if we go through, she got 4 incorrect and 1 correct. Now we're
The
on
man can
to
walk 5 miles in 1 hour. How many miles will he walk if he walks for 6 hours? So when he walks for 1 hour, he can go 5 miles. So what if he walked for 6 hours straight? How far would he go?
okay, and now we're on the extending multiplication. Remember, this is rate and comparison. This is just can they take their knowledge from equal groups and apply it, because rate is more of a a measure of time or money, or in comparison is something 2 times as much or 3 times as much. So this is, can they connect what they've learned about multiplication to different scenarios of multiplication?
So 1 hour straight or 5 hours straight?
So the man can walk in 1 hour, he can walk 5 miles. Okay, but he doesn't walk for just 1 hour, he walks for 6 hours. So how far did he go?
I'm gonna say 5.
5, you think? And how'd you get 5?
I just went 5 because it's 1 hour.
Okay, incorrect. And her strategy, I wasn't really sure what strategies, but she got it incorrect. So
It
doesn't
takes
matter
3
what
minutes to wash each window pane section. How long would it take for someone to wash all of the window panes? So you see this little part right there? It takes 3 minutes just to wash one of those. How long would it take the window washer to wash all of those windows?
This is a very concrete picture.
27. I just went 36, 9, 12, 15, 18, 21, 24.
Okay, and you figured out by skip count?
Yes.
So 27 what?
Windows?
Well, remember, it takes them 3 minutes to wash one window. So, yeah,
27 minutes.
27 minutes, okay.
Okay, next is multiplicative comparison.
Is the second lizard twice as long as the first? Explain why.
Well, the little one's on the floor and the other one's on the So kind of, the one needs about either 4 or 5. It's like 5 inches away. Count
5 inches away. So, but the question was, is the second lizard twice as long as the first?
The second one is
Yeah.
the big one.
Yeah, the second one, what? It's not twice as big. How do you know that?
Because it's longer than the other one and it can't go just shrink.
Okay, but I'm asking you, so is the top one is the first lizard, and the bottom one is the second.
And the thing with this section is, if you take a look, multiplicative comparison, it has all those. It really is they either understand it or they don't, okay? And what you're looking for, they're either going to say yes or no. So they have a 50% chance of getting it right by guessing. So they have to say like, oh, because 2 times multiplying by 2 is the same as twice as much. You're looking for some type of explanation that shows that they understand when you're multiplying by 2 or 3, that that's twice as much or 3 times as much. If they say yes, it is, but they can't give you an explanation, then they can't get credit for that.
Lizard. So it's saying, is the second lizard twice as long as the first lizard?
I'm gonna say no.
No? Okay. Alright, and can you tell me why you say no?
Because the second lizard is at the 8. And the first one is at the 4, and I never ever saw an animal shrink.
Okay.
So
Alright.
Okay, and now we're on to the second multiplicative comparison. You'll get some interesting answers when you get the multiplicative comparison.
Does the second dog weigh 3 times as much as the first? Explain why.
well, one, it depends because if that's a dog and it's bigger than the other one, so it weighs more.
But does it weigh 3 times as much?
3 times as much?
Yeah, so does the second dog weigh 3 times as much as the first one?
No.
No.
More.
And can you tell me why?
Because it depends on the size. Now, I have a puppy at home and then another big dog at home.
Okay.
So, yeah, and my big dog is 70 pounds.
Okay.
And the little dog's only like, I don't know.
Okay, we're gonna go to the next one.
So she got their answer. She said no, but her explanation was not satisfactory. So for that section, she got 3 incorrect and 1 correct. Okay, we're now going on to the multiplicative connections part. And again, this part is either going to be, you have to, it's subjective to the extent that they have to explain to you that they understand what you're looking for. So for this first one, for 3 times 8 equals 24, what you want them to say for 4 times 8 is, well, I just knew that I had one more group of 8, so I would add to it, okay? You're looking for something to explain that, they just had to add to what was there.
3 times 8 equals 24. Can you use this problem to help you find 4 times 8?
Yeah.
Okay, how can you use 3 times 8 to help you solve 4
Well,
times 8?
because it goes 3, 4, and then there's 2 8s, and if I say 24 was in there, I can just, and then there's 2 problems on the paper. So 4 is just one level up from 3, so if that's 24, I think that's 25 because it's just one above it.
Okay, so you're saying if 3 times 8 equals 24, 4 times 8, it would equal 25 because it's one more above it?
Yeah, because it goes 3, 4.
Okay.
All right, and the next one has to do with 6 times 4 is 24, using that multiplication fact to help you with that division fact. What you're looking for them to say something as, well, 6 times 4 equals 24, so 24 divided by 6 has to be 4, or 24 divided by 4 would equal 6. You want that some type of connection where they're immediately able to explain one from the other.
Problem says that 6 times 4 equals 24. How can you use 6 times 4 to help you solve 24 divided by 6?
Well, you could do that, switch it, change it, rearrange it.
Okay.
No, I mean not that. If you look at it, you can.
Remember earlier we talked about sort of band-aids, switch it, change it, arrange it, is one of those things where a teacher along the way somehow told her, when they're doing fact families, switch it, change it, arrange it sort of procedure.
You can either just count by sixes to get in your answer, or you can do a equation like this way and not.
Okay, so what would the answer be?
6, 4.
Okay, so can you explain to me how you could, so you solved it, right, by skip counting, but could you have solved it without skip counting?
Yes.
And so how would you have done that?
Well, besides skip counting, in second grade, my teacher taught me that if some equations tell you the answer, they're right there, they tell you the answer.
Okay, so you just use the equation to help you find that answer?
Only in some problems, not all.
So if they solve it, she solved it and she told us that, yeah, 4 is the answer. She skip counted, that's fine. But we're not looking for we want her to get the answers through using the multiplication problem. And she was not able to do that. So remember, it's not about them getting the answer. It's their explanation for how they got that answer. And they have to somehow connect it back to that multiplication problem.
Gotcha,
Because not all problems say the answer.
Okay.
So for the first two, sorry, I did not hit the button, but unable to explain or connect for both. And here's the third one now.
Can you give me a multiplication problem for this array?
4 times 3.
What's that equal?
4 times 3, 12.
Okay. And
We're not worried about, is it 4 groups or is it 4? We're not worried about, is it 3 groups of 4 or 4 into 3 groups? So if they just say 4 times 3 or 3 times 4, don't feel the need to differentiate. You want to see, can they immediately come up with a division equation for this one now?
can you give me a division problem for that picture now?
3 divided 4.
Okay, and what would that equal?
12.
Okay, so 3 divided by 4 would equal 12. Okay.
So for multiplicative connections, and this was sort of predictable because if you remember her equal groups, she wasn't bad at her equal groups. She has some skills in place, but when we went to division, she struggled. And what is multiplicative connections? Do you understand the inverse relationship between multiplication and division? She doesn't have a full understanding of multiplication yet, so she obviously isn't going to be able to use what she knows about multiplication to help her with division. So it makes sense. Earlier in the test predicted how she was going to do on this part because she's not there yet. She doesn't have a full understanding of equal groups. And we know when we go back and do instruction, that's exactly what we'll have to focus in on. And the last part we're going to be doing is multiplying by multiples of 10.
Now I'm going to ask you some multiplication problems. Answer the best you can, okay?
Okay, 10, 20, 30.
So what you're looking for is 8 times 10. It should just be 80. If they're counting by tens, it means they're not fluent. And remember, we're measuring this because if they're going to use more advanced, 2-digit and 3-digit multiplication strategies, they have to be able to multiply by a single digit number times 10. And then a 2-digit number times 10, and then a multiple of 10 times a single number digit, and then a multiple of 10 times a multiple of 10.
8, 60.
Okay.
You're gonna try to count by tens 14 times.
No, I can't use 10. 40.
Okay.
Yeah, I can't figure it out.
Those ones are hard. Okay. All right, we'll get that. We're gonna stop then. Okay.
All right, and that was the last part of the multiplicative thinking assessment. This assessment can go pretty quick. If students do really well, they can get through it really, really fast. Okay. So now what we would do is we would go ahead and you go back to your final sheet, and your final sheet would be filling out that front sheet. So if we take a look here, we already had her skip counting was a level B, her multiplication division facts were level B. She was a level B for her equal groups. Her division, she was a level AA. And remember, when you go through, it'll tell you, okay, if they get 2 or more incorrect, they automatically are a level AA for division. And if they get 2 or more incorrect on rate comparison, they're automatically a level A. And up here, for equal group spend, there's 8 problems if they get 3 or more. So it's a 65% or less. You don't even have to do the calculation. Just look, if they get more than 3, they automatically default back to this. So they're level AA. And the reason is why they default, because these are not difficult problems. So if they're getting 2 or 3% wrong, it means there's a hole, there's something missing. Okay, and let's take a look right here. It says if percentage correct for any problem structure is equal to 65% or less, the student automatically goes to AA for that problem structure. The next one says, and we're going to be doing a little bit more of this in another slide, if 2 levels are equal, the lower of the 2 is equal, which means is, say she would have had like 3 level A's and 3 level B's right here. You always go with the lower level, because if a student's going from skip counting back to counting by ones, there's something missing if they keep dropping their strategy for some reason. So you always assume and go with the lower strategy if they show 2. All right. The next one, this is a big one. It says for level C partial multiplicative reasoning, if a student shows both level B and level D, you combine them for a score of level C. So I'll show you that in a second, what that looks like. And then her multiplicative connection, she was a level A, and her multiplying by multiples of 10, she was a level A. And this is just the student progress monitoring sheet. And if you go through and you put her scores in here of what the scores are, she would have been a B, a B, A. And this is just where we can write down some notes, some things that we want to work on with her. And now we're going to do a real quick part of scoring, because we don't have a lot of experience with this. So take a look at this one, right? If we had a student and they just took this test on equal groups, what level would they be? And remember, this little cheat sheet down here is for you. So they got 1 incorrect, then they're level A, and then they had 3 at level B. And so the most fall in the level B. And remember, this is important. We're trying to get a snapshot in time of their strategies, right? And what research has shown is when you watch and pay attention to what children say and do, that tells you how they're thinking. And so we're just a snapshot in time right now, and we're just trying to figure out where they're at with their thinking so we can help improve their instruction. So this student right here would be a level B. All right, now take a look at this student. This is important. See how this is shaded in? It has arrows. It means whenever there's one that's in level B and another one that's in level D, both of those get added up. So this would actually be they'd have a 6 in level C. And the reason is, remember, level C, they show that they have multiplicative reasoning, but they also float back between sort of skip counting, additive composition. That's why they're considered to be partial. So if there's 3 there and 3 there, it automatically goes in there, and that would be 6 for level C. So it'd be 6 there to 2 down there, and that would be a level C for them. All right, let's take a look at this one now. Equal groups. They got 3 incorrect, and then 3, and then 2. And we know that anytime they get 3 or more incorrect, they automatically default to level A, and they would be level AA. And remember, these are just hypothetical. It's not often you'll see students who are skip counting also get 3 wrong. Normally kids who get a lot wrong are also level A kids. All right, let's take a look at this one. They have 4 level A and 4 level B. Again, this is really rare to see this, but if 2 are tied, you go with the lower one. So it would be a level A. And take a look at this one. Now we're on problem structures for division, right? Division. And you take a look at division as 2 or more incorrect, you automatically default. And remember, a lot of students, there's 3 measurement division problems and 2 partitive. So a lot of students do get 2 wrong, and it usually is the partitive division ones. So again, they would default, and they would be a level AA for that one. Take a look at this one. Level A and level B, and take a look. They aren't tied, so there's more in level B, and so they've shown level B, so they would be a level. They showed more thinking towards the level B level than level A, so they'd be classified as level B. All right, take a look at this one now. They have 1 incorrect, 1 here, and then they have a B and a D. Remember, whenever there's 1 and a D and a B, these combine, so there would be 3 for level C, and then an A in this, so they would be a level C for that one. Okay, and let's take a look at this one now. 4 for level D, and then 1 incorrect, and that would be a level D. Now, multiplicative comparison, again, if they get 2 or more incorrect, they automatically are this. And this is a really common score. Most of the time, kids can do okay with the rate, but when they get to the multiplicative comparison. So if they're a level AA, just realize, okay, they had the rate, we just need to work on the multiplicative comparison. Or they may have got the rate problems wrong and the multiplicative comparison ones. All right, take a look at this one. We have 1 here, 1 here, 1 here, 1 here. Remember, level C pulls in everything that's done in B and D, so there'd be 2 in C, 1 there, 1 there, so they would be a level C. And this last, and that was it. So after you give the multiplicative thinking assessment and then you record their data on the student progress sheet, you're going to go through and you're going to go to the multiplicative thinking framework and you're going to plot their skills. So this is what her skills looked like. So remember her skip counting, her multiplication division, her equal groups, and this is where we make our decisions from. So this is actually a lot easier than the primary plotting because all you're focusing on are going to be 2 things, right? No matter how they do on the rest of this, your first question you ask yourself is, were they level D? If they're not level D, you're always going to start working on multiplication equal groups until they're level D. Once they're level D, you just make sure that they can do, 1 more group, 1 less group. And then remember, the division connection, where it's with missing factors, you're multiplying missing factors, starts at level D. That's what you are going to focus in on. After that's all in place, level D, then you'll go ahead and go down and work through division. And then after division, you'll go to the extending multiplication. And then you'll go to the multiplicative connections and multiplying by multiples of 10. And remember, once everything is in place right there, then you'll go ahead and you can start working on multi-digit multiplication division. So again, in summary, this is almost like a checklist that you can go through. Check their equal group score. Remember, all you care about are equal groups and also their basic skills. You're always going to have a basic skills type thing that you'll be working on too, whether it's skip counting or their facts. You always need to know how strong they are with their facts, and more importantly, are they using their facts? And then equal groups, okay? So check their equal groups. If it's not a level D, work on equal groups. If it is a level D, remember, just make sure they can do the 1 more group or 1 less group. That might be a week of instruction for some kids, but most kids have no problems with that at level D. And then remember, move on to level D plus, which means the division connection through multiplication of missing factors. Then you move on to division. And remember, if you put the time in level D, and you do the division connection, when you get to division, it'll be much easier. Number 2, always check their basic skills. Decide what basic skills need to be addressed. Until equal groups is level D, ignore the rest of the framework. Only work on equal groups and basic skills until they're level D. And remember, you're going to test students. They're going to have a lot of things to work on. You only work on 1 structure at a time because the way that this framework is designed, it goes from the top to the bottom. You have to have equal groups in to have division. You have to have division in place to have multiplicative reasoning or multiplicative connections in place. So all these things are all connected to each other, okay? And so you remember, your focus is just going to be on this top area, and then the rest will go. And then once equal groups is in place, work from the top to the bottom, equal groups, then division rate, multiplicative comparison, connections, multiples of 10, and so on. So this is just a quick, when you're thinking about your instructional time, and it's a suggestion, okay? The big word is suggestion. You don't have to follow this, but when you're working with level A, you want to spend about 70% of your time working on structures, then 30 working on, the basic skills. What's nice about level A is the skip counting is already ingrained into the lessons, so you don't really have to do a separate thing. Remember, for level B, these are students who we're trying to get them to create equations. So we want them to really focus in on the structures, right? Groups, number in each group, or multiplicative and multiplier. And then basic facts, which could be, or basic skills, which could be skip counting. But most of them will probably have some form of skip counting in place and working on their facts. Now remember, level C is tricky. Are they a level C because they don't understand the structure, right? But they have their facts. So, or are they level C because they don't have their facts but they do have the structure. So remember, level C kids are very close to level D. Most of the time it's just because they don't have the facts in place. But sometimes level C kids will have the facts in place, but they're just not connecting it to what they, connecting it to the problem. So level C is, it's not confusing, you just have to know. Are you gonna be focusing more on structures or more on basic skills? And their data will make that decision for you. And then finally, level D, it's like, well, problem structures, they're already smart. Remember, why would we be instructing on problem structures? Because we're working on that division connection, okay? So we want to teach them about the structure, the connection, the inverse relationship. And again, you're not going to spend a lot of time on facts because they already have the facts in place. So this is just some as suggested instructional times. Okay, in your folder too, you'll see this is the lesson plan. It looks, it's really big. It looks overwhelming, but it's just basically this. Pick your one area. Remember, you're going to work on one type of structure at a time, whether it's multiplication or rate or multiplicative comparison or division or whatever you're working on. You go ahead and this would just be where you fill in your information for there. Remember, you'll always be doing something with one of the basic skills, whether it's skip counting or multiplication of facts, or you'll be working on one of these structures and deciding what you're going to do with those structures. And then the rest of these will just be blank. It's not like you're working on all these every single day. You just work on whatever problem structure you're going to work on, and then you're going to choose your basic skill that you'll work on. And for example, for this one, you could say, okay, Monday through Thursday, this is when I'm going to work with these students, and we're going to work on equal groups. And then you could say, okay, on Tuesdays and Thursdays for the first 4 minutes, we're also going to work on skip counting. Okay, so now we're going to go through all the things that you'll be receiving today for free, and then I'll show you guys where you can go to get these materials, okay? So you'll get the multiplicative thinking assessment, which is a very important piece because everything is centered around the data that comes from that, right? You'll get the multiplicative thinking framework, which you'll need to use that to map out their thinking, and then you'll use that framework to sort of choose the order in which you're going to teach things. Also important is the activities guide, because you just look up the level and it's going to tell you exactly what you're going to be working on. Remember, all these tools that are in that multiplicative or the level activities guide are with the materials that you guys are receiving for free, okay? The developing skip counting book and the developing fluency with facts book, and then you'll have a bunch of different teaching models that are also included that you can use to develop these things. But from, if you watch the primary numeracy webinar, you know that there's also the e-library. And the e-library you do not have access to. You actually have to pay to have access to the e-library. And the e-library has the multiplicative thinking book. Remember, that's the workbook that you would work with the students when you're actually doing your mini lessons, okay? And then the actual lessons that we went through, most of these. I don't think we got into the multiplying by multiples of 10 or the multiplication, the comparison and rate one. But we did get into the division one a little bit, and we spent a lot of time with the multiplication ones. These are your mini lessons. Remember, these can be taught through Zoom or whatever. And then the best part of this is the independent thinking, and you saw the clip at the very beginning of what the independent thinking clip looked like. So we'll just go through pricing right. So we'll go through pricing right now, so you know what it costs, and we'll take a look at bundles and everything else too that's in there. So let's see, we'll go down here and then right here. There you go. So if you go through and you're looking for how much a license is just for the multiplication division, multiplicative thinking, it's $195 for an individual user license, which goes up to 30 students. If you want to buy a school license, and what a school license does, it covers every single employee and aide in the entire school, and then you have universal access to anyone who works in the school has rights to use the license, and you can use it as school-wide. And again, it's $950 for a school license. If you go through and you wanted to get the school bundle, where it's the primary numeracy program, the multiplication division one, and the fractions one, it's $1,850 for a school license, and that's not a subscription. It is a one-time fee, and then once it's paid for, it's yours forever, okay? And finally, a district license, it's $850 per school for the multiplication division e-library, And then if you can get that as a bundle with all 3 programs, be $1 or $1,650 right there. And again, if you take a look up at the individual user one, to get the bundle for all 3, it'd be $395. If you want to pay by credit card, just click on that link there, and this is in the drive. So I'll show you now where you need to go to get access to the free materials and all the assessments and everything too. So all you'll do is you will go to numeracy. Oops. You'll go to numeracyconsultants.com, and if you just scroll to the very bottom of the page, what you'll see is there's a copyright at the very bottom of the page, right? And if you put the cursor on there, it'll light up, and then if you click on it, you're going to go, and the first thing you'll see is the primary numeracy. And then if you take a look, you'll have the multiplicative thinking materials. So you'll go ahead and you'll click right here, and then it's going to go ahead, and there's some things that are in here. Just so you know, there's a couple videos that show you how to use some of the free materials that you cut out, and it just shows you activities that you can do for that. There's obviously the order formers right there. Right here is the breakdown of the multiplicative thinking webinar. So if you want to go back and just watch the assessment, you're not frantically searching through, you can go, it'll, say 52 minutes and 13 seconds. You can go ahead and do that. You have the Developing Fluency with Facts book, the Skip Counting book. You also have, this is just a sample of the multiplicative thinking independent assignment. It goes over earlier how to use that as well. Then up here you have, your assessments. Your assessments are in here. You have your assessment, then you have the slides that you go through with them. You have in the curriculum folder, you have the leveled activities guide, which would be right here. You have your frameworks. Also for curriculum to see the standards that line up with it. If you're in Texas, we have a TEKS one. We just don't have it in the folder because a lot of, we would put Common Core in the folder, but we also have a TEKS one that lines up with Texas standards as well. And we have the Math Fact program. So this one, I can't really explain it to you, but there's a video. It's like a 10-minute video. And it's really good for sort of structured teaching, having your kids do really focused practice. So it's a nice supplemental piece to have to use with the rest of the program. So let's go. So we'll go back to the website and I'll just show you this. There's a games page. Most of the games are for the numeracy, but there are a couple for multiplication division at the very bottom, I believe. Yep, there's multiplication division. So there's a couple games on the games page. There's other intervention programs as well. There's the primary numeracy. If you're not aware of that, there's the multiplicative thinking one. There's also a fractions one, which is actually a very, very, very good program, very targeted. And fractions is definitely an area where many students, and not just students, but schools are struggling with right now. And also we have professional development packages. So say you end up deciding that you want to buy a license, and as you're using it, you realize there's a lot of materials and you're just a little confused. We do offer support professional development sessions to help people get started. If you go with a school or district license, most people like to have, trainings, and it's supposed to be a sustained model where it's not just one training. We'll come and train, and then we'll do follow-ups. And the idea is to make it so schools are self-sufficient. So you don't need to have trainers after that. So you'll have people on staff who are very familiar with it. So we have professional development plans as well that goes with everything. If you have any questions, you can go ahead and just go to the contact page. You can email us at info@numeracyconsultants.com. And that is right here. Please also, if you found this to be really useful, please share this. Feel free to post on social media or email it to people. We've had up to right now, I think over 5,000 people have viewed all of our webinars combined in just the last year. So we've had a lot of people who have come across our materials, and we're growing very rapidly as well. So if you have any questions, feel free to email us at info@numeracyconsultants.com. And also, if you go over here, the order form, and I'll show you the order. This is, if you go to the store, there's an order form at the very bottom of the page, and you can print that, or you can order directly from the website if you want. So if you have any questions, please email us at info@numeracyconsultants.com. And thank you, and I hope you enjoyed today's webinar.